If we begin a journey into the philosophy of Mereology, we step into a very old, very persistent question. What is it that makes a thing be what it is, and how do its parts come together to form that unity? It is not merely a question about nouns like car or organ or statue. It is a question about the most basic relation that underwrites our everyday experience of the world, the relation of part to whole. When you look at a car, you don't just see a lump of metal and plastic. You sense a unity that arises from the way wheels, engine, chassis, doors, and seats are organized. When you listen to heart beating, you don't think of it as a random collection of cells, but as a living organ integrated into a living organism. When you admire a statue, you might notice the material existence of bronze or marble, and yet you also attend to the form that gives that material a definite figure, a definite meaning. Mereology asks, how do these different kinds of unity, material, functional, organizational, emerge from parts? And what does it mean to say that something is a part of something else, or that a collection of parts makes a whole? We will begin by wrestling with some core terms. What is a part? What is a whole? How do we define a sum, and what counts as a proper part? What is fusion in this context, and how does it differ from simple aggregation? And what does it mean for parts to overlap, to be in the same object, and yet extend beyond any single, clean boundary? These questions are not merely technical. They pressure our intuitive sense of identity, continuity, and change. The very idea of a boundary is central. When does a boundary exist between a part and a whole, and when do boundaries blur or shift as a thing persists through time or becomes mingled with other things? To approach these questions well, we must follow a long historical arc. We begin with Aristotle, who already had a powerful intuition that there is a deep connection between form and matter, a connection that underwrites the unity of a thing. Aristotle's hylomorphism, the view that substances are composites of matter and form, provides a first philosophical home for the problem of parts, because it puts at the center of unity a principle other than mere material copresence. The form, in Aristotle's telling, organizes and shapes the matter into a particular kind of thing. The unity of the object is explained not simply by an aggregate of bits of matter, but by the way form governs that matter. This is a kind of seed for the later idea that what we call a whole is not just a heap of parts, but a structured unity in which each part serves a role in the whole's nature. From that seasoned soil arose a strikingly modern turn, the work of Stanisław Leśniewski in the early 20th century, who gave us a rigorous formal system for dealing with parthood and fusion. Leśniewski did not merely object to everyday intuition, he sought to anchor mereology in a precise, logical calculus. He introduced formal notions of part, whole, sum, and boundary in a way that could be manipulated with the clarity of a mathematician. The shift from common sense to formal logic was not merely a pedantic move. It was a wager that the deepest questions about unity and composition could be clarified, hovered over by the exactness of truth-functional notation. If Aristotle's idea of form as organizing principle was a philosophical thesis, Leśniewski's work was a linguistic and mathematical thesis. How do we linearize or formalize parts so that we can reason about them without running into paradoxes or ambiguities? We will also encounter a cascade of later thinkers who push in different directions. Peter van Inwagen, a stalwart contemporary figure, defends a robust form of mereology tailored to the metaphysical issues of composition and identity. He asks, for instance, what it would take for a certain collection of parts to stand in as the same object over time, and how parthood preserves or alters identity. Then there is James Schaffer, who has pushed the analysis of unity and parthood into a more systematic study of how sums and wholes can be grounded, how they can fail to be grounded, and what it would mean for the unity of an object to be explained by higher-order relations or by the distribution of a thing's parts. And there are many other contemporary analysts who cross-reference these ideas with debates about material composition, the persistence of objects through time, and even the set theoretic notions that sometimes tempt us to model parthood as a kind of subset relation. As you listen, you will hear a through-line. The most enduring questions about mereology are the ones that ask how we move from the local to the global, from a collection of bits to a single, intelligible whole. How do the boundaries of a thing arise and persist? How does a thing remain the same thing if its parts are altered, replaced, or rearranged? And how do we reconcile the intuition that a chair has a certain unity with the surprising possibility that many different sums of parts might satisfy the same criterion of being a chair? Let us begin by defining the key terms that will recur across the discussion, so that you can hear the arguments with a map in mind rather than wandering in a fog of ambiguity. Parthood is the relation that holds between a part and a whole of which that part is a constituent. If A is a part of B, Then there is something about A that is included in B, and that contributes to B being what it is. But there are nuances, there are proper parts, parts that are not the whole itself. There are overlapping parts, parts that lie within the same whole, but that may also lie within other wholes. Then there is fusion, or the mereological sum, the whole that is formed by bringing a group of parts together into a single object. A car, the body and the wheels together, the statue formed when the material and the form are taken as a unity. These are all different varieties of sums, or at least they invite us to think of sums in multiple ways. Then there is the boundary, the line, surface, or interface where the parts meet, or where the unity of the whole is seen to be constituted. The boundary is not just a physical barrier. It is a conceptual dividing line that helps us understand where one category ends and another begins, where the part stops being part and becomes the whole, and where the identity of the object is to be found. The unity issues that motivate mereology often come from the same practical domain as everyday experience. We want to know what holds a thing together as a single object through the vagaries of change, transformation, and interaction. Do the wheels of a car constitute a proper part of the car even when they may be replaced? Does the boundary that marks the end of a wheel's function to the car's functioning also mark a boundary in parthood? If you detach a wheel, does the car still exist in the same sense? Or does it become a different sum, a car with a different set of parts? These questions show why mereology is not sterile philosophy. It is deeply connected to questions of identity, persistence, and what it means for a thing to be what it is across time and circumstance. To ground this exploration in a concrete narrative, let me invite you to imagine 3 in-depth case studies. The first is a common object we see every day, a car and its wheels. We will examine what counts as the parts of the car, what counts as the whole, what it means for a wheel to be part of the car, and how changes in wheels affect the unity and identity of the car. The second case study will look at a living organism and its organs. Here we confront the problem of where boundaries lie between something that is alive and something that is not yet an organ, and where an organ ceases to be an organ as it's damaged or reorganized. The third case study concerns a statue, a composite of material and form. In this case, there is a tension between the matter, the bronze or marble, and the form, the figure or shape that gives the material its significance. Each case will reveal not only the intuitions we bring to ordinary objects, but also the philosophical problems that get sharpened when we ask, what is the parthood relation that makes the thing one? Let us begin with the ship of Theseus, a thought experiment that has traveled through philosophy as a kind of parthood parable. The story goes something like this. A ship has all its planks replaced, one by one, until none of the original material remains. Is it the same ship, then a twist? If all the removed planks were collected and assembled into a ship, which of the two is the original ship? The thought experiment is often framed as a puzzle about identity over time, but it is also a parthood puzzle. When we replace parts, do we still have the same thing? When we collect the old parts, do we still have the same thing? The ship invites us to test the assumptions we have about part-whole relations. It presses on the intuition that a thing's identity is tethered to something stable, perhaps to a form, perhaps to a continuity of matter, perhaps to a principle that binds its parts together in a way that is not reducible to the mere ostensible sameness of materials. The ship of Theseus is also a good way to see how historical anecdotes can illuminate very abstract concerns. In this case, the more general question is, what makes a given arrangement of parts a single object rather than a mere collection? Aristotle had long argued that form is the principle that gives unity to matter, that you cannot separate the shape from the matter without destroying the thing's essential nature. He did not adopt a purely anti-parthood stance. Rather, he embedded parthood in a broader metaphysical view that understands unity as something that emerges from the arrangement and organization of matter by form. The ship, then, is a test of whether unity is a matter of continuity of substance or continuity of organization or something else again. Then there is the more formal historical line that leaps forward to Leśniewski. Consider the radical shift from saying parts are things that fit inside wholes to saying we can define a part with a precise relation that obeys logical rules. Leśniewski did not pretend to replace experience with arithmetic alone, but he did insist that the relations of part, whole, sum, and boundary could be expressed with a formal vocabulary that makes the structure of arguments transparent and testable. He wanted a system in which the mereological notions could be used to derive consequences and solve paradoxes. The shift from a philosophical intuition to a rigorous logical calculus is not merely technical. It changes what counts as a legitimate question and what counts as a valid answer. If you can express a problem in a formal language, you can sometimes see that the problem dissolves or at least transforms in light of the rules of the system. Leśniewski's early 20th century formalization is a landmark not just for Mereology, but for the broader idea that philosophy can be augmented by mathematics in a way that makes even the oldest questions more precise. As we move through this history, we also encounter some important countercurrents and refinements. There are critics of the strong parthood paradigm who worry that too rigid a theory risks divorcing our everyday sense of material composition from the logical formalism. The more you axiomatize, the more you risk creating a dry, exotic island where the ordinary way we speak of a chair or a glass of water no longer maps neatly onto a formal structure. This tension has fueled lively debate in the late 20th and early 21st centuries, with contemporary analysts pushing back against what they take to be overly metaphysical abstractions and offering more tractable theories that connect to questions about identity over time and the persistence of objects. Let us now move toward the case studies, where the abstract questions become concrete and where the logic of parthood and fusion begins to feel palpably relevant. Our first case study is a car and its wheels. Imagine a car in a showroom, a moving vehicle with an engine, a chassis, doors, seats, and wheels. The wheels as parts have their own subparts: tires, rims, brake components, and perhaps even the air inside the tires. The car's body contains material parts as well as functional parts. Now, what counts as a part of the car? Is a tire that is mounted on a wheel a part of the car? Yes, many would say so, because removing it changes the car's composition and its ability to function as a car. But what about the hubcaps or the wheel rims themselves? They are parts, but they are also themselves comprised of subparts. The car's wheel is a composite that participates in a union with the rest of the vehicle, yet the wheel also belongs to other sums. A wheel is a part of the car, but a wheel plus the other wheel might form a different sum, two wheels forming part of the car together, or all four wheels plus the car's body forming a larger sum. Consider the potential trouble points. Could the same wheel be a part of two different wholes at the same time? That seems possible if the wheel is mounted on two different vehicles, such as a shared carpool arrangement or a race where a wheel might be temporarily swapped between vehicles. In ordinary circumstances, however, we treat the wheel as belonging to one car at a time. But this is precisely the sort of scenario where the formalization of parthood and fusion must be robust. Can a single part simultaneously be a part of multiple wholes, and if so, under what conditions? Leśniewski's framework helps us see how to express such possibilities without contradiction by carefully delineating the domain of discourse and the rules that govern when a part belongs to a given whole. The problem of multiple occupancy of a part, A is a part of B and of C at the same time, is a classic problem for any mereology that wants to capture the richness of real-world situations. Some theories bite the bullet and allow for multiple parthood, while others impose restrictions or reframe the concept of part so that it cannot be used to license contradictory ascriptions. Now look at another dimension of the car case: boundary and unity. Where is the boundary of the car? Is it at the outer shell of the chassis, at the interface where the tires meet the road, or at some deeper boundary between the car's biological-like identity as a system and its environment? The boundary question is intimately tied to unity. If you replace the entire set of parts of a car over time, is it the same car? If the engine is replaced, if the doors are swapped for new ones, if the tires go on a different rim, does the car remain the same? The standard mereology would say, as long as we keep the same functional organization and the same historical root of parts within a certain continuity of matter, we preserve the car's identity. But there is more nuance. You might change a part in such a way that the whole changes its function or its categorical identity. A car that loses its wheels ceases to be a car in the same sense. It becomes something closer to a chassis or a platform rather than a car as a functioning vehicle. If we were to completely replace the car's parts, but the parts themselves were traceable by a continuous material lineage, would that matter? The ship of Theseus becomes a practical metaphor here. What constitutes the unity of the object if the transformation is complete? Our second case study is a living organism and its organs. Here, the parthood question takes on a deeper life because living systems are not mere mechanical assemblies. They display a remarkable integration. An organ such as the heart or liver is composed of tissues, cells, and molecules. Yet the organ's role within the organism is crucial to the organism's overall function and persistence. Ontologically, one might ask, is the heart a part of the organism? Is the organism a part of something larger, like a biological system or an ecosystem? And what does it mean for an organ to be a part of the organism if organs can regress, reform, or be reconstituted through regeneration? The unity of a living organism is often explained through its organizational coherence. the organs interoperate to maintain homeostasis, development, and reproduction. The heart's pumping action is coordinated with the brain's regulation and with the lungs' oxygen exchange, and this coordination is what sustains the organism as a single living entity. Here we encounter a crucial tension in mereology, the need to distinguish mereological parthood from biological or functional unity. The heart is a part of the organism in a straightforward sense. Yet the heart's existence depends on the organism's function and on the system-wide architecture in which it participates. If the heart were to be transplanted to another organism, the parthood relation shifts and the question arises. Does the heart remain the same part when it is placed in a different whole? And what about organ transplantation and regenerative medicine? If you replace a damaged heart with a donor heart, is the donor heart still the same part of the recipient organism? Philosophers like van Inwagen have argued that mereology must be compatible with the fact that organisms persist despite a flux of their parts. His approach invites us to think of the organism's persistence as a relation between the parts at different times, rather than a simple, static structure. He argues for a robust account of composition. Under certain conditions, parts compose an object. The conditions are not trivial. It must be the case that the parts exist in the right kind of arrangement and causally interact in such a way that a unified object emerges. A related set of issues concerns the unity of the organism's boundaries and the object's identity through growth, aging, injury, and regeneration. The boundary is not as simple as a skin boundary. It is also a boundary of function and organization. The skin is a boundary between the organism and the environment, but the boundary between organ and tissue is more subtle. Is the boundary a physical boundary, or is it a boundary defined by a pattern of organization? In some respects, a kidney is a collection of cells that together perform a function essential to the organism's life. If all the kidney cells were to be replaced by new cells while maintaining the same function, does the kidney remain the same organ? What if the organ's function were altered in radical ways? These questions shape the way we argue about parthood in living systems. They also connect to broader questions about identity over time. Does the organism's identity track the continuity of matter, or its continuity of organizational structure, or some combination of both? Our third case study concerns a statue, a composite of material and form. Here the problem is perhaps most obviously philosophical, because a statue is, on the face of it, a paradoxical blend of the material world and a human intention. A statue is a chunk of bronze or marble that has been shaped into a particular figure. The material provides the boundary and the substance, while the form provides the unity and the meaning. The parthood question becomes, what parts constitute the statue, and what is the sum that makes up the statue? Is the statue simply the sum of its material parts, bound together by an external sculptor's intent? Or is the statue's unity largely due to the form, the arrangement of materials into a coherent figure, that gives it its identity? If you were to melt the statue and reforge the material into a different figure, you would have a different object with different unity and different parts. But if you carved a statue that exactly replicates the original's form, even with different material, is it the same statue? The questions proliferate and become especially intricate when we consider partial forms, or the possibility that a statue could be in two places at once if the same form is realized in two different bodies. In exploring these cases, we also begin to notice the way mereology intersects with other domains of philosophy, especially identity over time, the unity of objects, and the relationship between parthood and material composition. There are cross-references that illuminate these connections. For instance, when we ask whether the same wheel can be part of two different sums, we touch on the problem of identity over time. As a system evolves, what keeps the identity of the whole intact? In terms of unity, we encounter a direct link to the idea that there exist different theories of unity. One might appeal to a theory that grounds unity in causal interactions among parts. Another might ground it in the formal structure the parts contribute to the whole. And when we talk about material composition, we confront the set theoretic temptation to model parthood as a kind of subset relation, and the associated pitfalls, such as the possibility of strange, non-intuitive sums that nonetheless satisfy the formal conditions of a theory. Let us broaden our map by outlining some core concepts that appear repeatedly across the discourse. Part versus whole is not simply an empirical fact, but a philosophical distinction that invites us to examine how the whole emerges from its parts. Boundary is the interface that helps determine where one thing ends and another begins, not just spatially but conceptually. Unity is the property that makes a collection of parts cohere as a single object. It is something we can speak about in different ways: causal unity, functional unity, organizational unity, and perhaps even numerical unity. though that last one is controversial in some theories. We also need to keep in view notions of fusion and sum. Fusion is the act or result of gathering parts into a single object. A sum is the resultant whole that the parts compose. Two more terms are crucial. Overlap and identity. Overlap is a relation that can hold even when neither of two wholes contains the other as a whole. Two objects can overlap if they share some part. Identity, in turn, becomes the central question when we think about persistence through change. Is the identity of a thing determined by its parts, by its form, or by the functional relations among its parts unless something else explains it? Throughout this journey, it is useful to distinguish between three broad philosophical approaches to mereology. The first is the classical view, which treats parthood as a primitive, unanalyzable relation that is simply given in the world. In this view, the parthood relation is used to build a rigid theory of composition. Objects compose if the parts meet certain criteria, and the computation of sums and boundaries follows from the parthood relation in a straightforward way. The second is the formalist view, exemplified by Leśniewski, which aims to axiomatize parthood, sum, and boundary to ensure that the theory is internally consistent and free of paradoxes. In this approach, one becomes more cautious about intuitive vagueness and more attuned to the logical structure of mereology. The third is the functional or teleological approach, which asks whether unity is to be grounded in the function that parts fulfill within a system, or in the causal, dynamical relationships that bind a system together through time. Each approach has its strengths and its limitations, and modern debates often weave together insights from all three. As we move through the arcs of history and into the present, we should not forget the critique and revision that have accompanied these theories. For example, some contemporary analysts have argued that parthood should not be treated as a single, universal relation. Instead, there might be multiple parthood notions, each tailored to a different kind of composition. One sense of parthood for solid material composition, another for functional integration, another for temporal persistence. The idea of multiple parthood notions helps to accommodate the rich variety of real-world cases where a given part might belong to one whole in a functional sense but belong to another whole in a spatial sense. This pluralist approach is a significant departure from a simple, uniform theory and reflects the complexity of the world we inhabit. We now turn to the cross-referencing that helps connect mereology to other fundamental topics in philosophy. One important cross-reference is to identity over time. If a car's wheels are replaced over time, does the car's identity persist? If a statue's material is replaced, does the statue remain the same object? These questions tie mereology to the broader metaphysical problem of persistence. What makes an object endure through change? The identity over time problem asks us to distinguish between the continuity of material parts and the continuity of organizational structure. Some theories answer with a strong emphasis on the continuity of matter, some with the continuity of form, and some with a more nuanced combination of both. The mereological problem is often the crucible where these debates are sharpened. Another cross-reference concerns the unity of objects and the notion of boundary in relation to set theoretic notions. If parthood is read in a way that mirrors set inclusion, we might be tempted to translate mereology into a kind of set theory. The parts are members of the set that constitutes the whole, yet there are deep differences. Set theory treats a set as a collection with a purely external membership relation, whereas mereology concerns the structural role of the parts within the whole, the way they contribute to the whole's organization and function. The boundary in the mereological sense is not merely a marker that separates elements of a set. It is a functional and organizational boundary that helps define what the whole is. The cross-reference to set theory invites a careful analysis. Would modeling parthood as set inclusion produce the same intuitive results as a robust mereology? Often it does not, precisely because mereology cares about the unity and the causally productive role of the parts, not merely about what is included in what. Now let us step back and consider the history anecdote that recurs with force in these discussions. Aristotle's hylomorphism as a precursor to parts and form. Aristotle does not reduce things to their parts alone, nor does he insist that every part be a separate thing. He sees the form as a principle of organization that gives shape to matter. The famous line that captures this tension is often paraphrased as, "Form gives unity to matter, and it is the form that makes what counts as a thing." This is the seed of the idea that unity does not arise merely from the accumulation of parts. Unity arises because a form organizes those parts into a structure that has a determinate function, a determinate purpose, and a determinate relationship to other things. The critique you hear in contemporary mereology is not that Aristotle was wrong to emphasize unity. Rather, it is that his system requires specification for how form becomes a part of a more general theory of part-whole relations, and how the boundary is defined in the case of existing things, that is, in the case of real objects rather than mere theoretical constructs. We also recall a crucial anecdote about Leśniewski's early 20th century formalization. In the Warsaw Circle, Leśniewski proposed a formal language capable of capturing the notions of parts, wholes, and sums with an eye to avoiding the paradoxes that plagued other, earlier theories. He was concerned with the precise logical structure of parthood. What does it mean to say that A is a part of B, or that A and B together form C? He insisted on meticulous definitions that would not yield contradictions when transposed into formal proofs. His work marked a turning point. Mereology could be made into a rigorous structure whose theorems could be tested with a formal calculus, much like geometry or set theory. His approach did not discard intuitive appeal. It sharpened it. The early demonstration that part-whole relations could be captured with a set of axioms made the metaphysical questions more tractable and more amenable to critique. As we travel toward the late 20th and early 21st centuries, we encounter critics and refinements of Leśniewski's program. Peter van Inwagen, for example, writes as a metaphysician who cares deeply about what exists, what can compose, and under what conditions a collection of things yields a new, unified object. He gives us a robust account of composition and a careful analysis of the conditions under which a sum exists. He is also concerned with the problem of temporary intrinsic properties, which concerns how properties can change with time while the object persists, an issue that interacts with parthood in important ways. If you imagine a car that loses a wheel and then regains one, you are confronted with a temporary shift in the parts count and yet a persistence of the overall object. Van Inwagen's program helps us think about what remains constant across such transformations and what counts as a genuine ontological change. James Schaffer offers another crucial strand of modern thought. He focuses on unity and the conditions under which a thing has a unity that justifies speaking of it as a single object. He gives us the sense that unity may be explained by higher-order relations, by the distribution of parts, or by prioritizing certain parts as more central than others. Schaffer's analytic energy is directed at clarifying how we should understand the relationship between parthood and the unity that underwrites our natural language talk of objects. His work reveals that the notion of unity is not a monolithic thing, but a family of related notions that can be applied differently depending on the context, biological, mechanical, or artistic. And in the broader contemporary landscape, other analytic philosophers push the discussion toward practical implications and computational concerns. Mereology has noteworthy applications in computer science, artificial intelligence, and robotics, where a robust account of how components combine, how systems persist, and how parts are swapped or integrated with others matters for the design of reliable, maintainable systems. The simple, crisp intuition that a part should be something that, if removed, would alter the identity or function of the whole has to be translated into the design language of machines and software. In AI ontologies, for example, a part-whole relation is crucial for representing the architecture of a system and for reasoning about its components. The same questions that trouble us about a car's wheels become technical constraints we can program into systems that manage assemblies, maintenance procedures, or the substitution of parts in a factory setting. In medicine, too, mereology informs our thinking about organ transplantation, tissue engineering, and regenerative medicine, where the boundary between parts and wholes is functional as well as anatomical. Let me close by returning to several of the core questions that have driven this inquiry, and by offering you a sense of the kinds of arguments and counterarguments you will hear as you explore more deeply. First, how should parthood be defined? Is it a primitive relation, as the classical view sometimes treats it, or can it be analyzed in terms of other relations, or perhaps reduced to a formal specification? The primitive view has the advantage of staying close to everyday language. We simply talk about parts and wholes without needing to derive every use from other concepts. The drawback is that a primitive relation may lack explanatory power, leaving us to ask why parthood holds and what its deeper basis might be. The analytic or formal view seeks to provide a precise account that yields clear theorems. The challenge there is to avoid paradoxes and to maintain intuitive appeal for ordinary objects. Second, what is fusion and how does it relate to the sum? Fusion, as a concept, is the act of combining parts into a whole, but does it always yield a new object with a stable identity? Or are there contexts in which bringing parts together does not create a new object, or creates several possible objects depending on the conditions that obtain during the combination, and what exactly counts as the sum? Is the sum simply the mereological aggregate of the parts, or is it something more, an object defined by the regime of relations that those parts bear to one another and to the whole? Third, how should we handle the overlap relation? If two wholes share some parts, do they overlap, and what does that reveal about the nature of parthood? Is overlap a charitable concept that allows for a kind of shared ontology, or does it threaten a clean, hierarchical picture of parthood in which a part can belong to only one whole at a time? Fourth, what are the reasons to prefer one theory over another in terms of unity and persistence through time? Does a theory of unity grounded in causal relations better capture how things hold together in the world than a theory that grounds unity in functional or organizational considerations? Or is there a synthesis that can accommodate the multiple ways in which unity manifests itself in the world? Fifth, what are the practical implications for science and everyday reasoning? The car, the organ, the statue, these examples are not merely curiosities. They shape how we talk about design, repair, conservation, and restoration. They influence how we conceive of identity in a world in which objects continuously change, parts are replaced, and new wholes emerge from old materials. When engineers design modular systems, when doctors plan complex transplants, when artists conceive of new compositions from old materials, mereology quietly enters into the decisions and the frameworks we use to understand and manage those decisions. And finally, what is the relation of mereology to the broader discussion of identity over time and to the question of unity in objects? The question, what makes the same car or the same statue across changing parts, connects mereology to the philosophy of time and to the metaphysics of persistence. If identity over time requires more than the sameness of parts, then mereology must be complemented by a theory of temporal parts or by a theory of endurantism or perdurantism, depending on which view of persistence you adopt. The unity a thing exhibits over time might require a more nuanced account that allows some parts to be replaced, some parts to be retained, and yet for the object to maintain its identity. The cross-fertilization of these ideas with parthood, boundaries, and unity becomes a fertile ground for further exploration. In this segment, we have laid the groundwork for a longer journey into the philosophy of mereology. We have traced a line from Aristotle's early intuitions about form and matter to Leśniewski's formalization, and on to the contemporary debates that animate philosophers like van Inwagen and Schaffer. We have examined core notions, part, whole, boundary, unity, fusion, sum, and overlap, and we have contrasted different theories of how parthood relates to unity and persistence. We have considered real-world applications and practical implications, and we have offered 3 case studies to illustrate the issues at stake. As you move forward, keep in mind that mereology is not simply a theory about abstract parts and sums. It is a lens for seeing how complex systems come together in the world. It helps us ask, what makes a car, a living organism, a statue both material and idea? It helps us ask where the boundary between part and whole lies, how a thing can persist through change, and what it would mean to claim that a part belongs to multiple wholes at once. It invites us to test whether the unity we experience in ordinary life is best explained by a form that organizes matter, by a logical structure that pinpoints part-whole relationships, or by the dynamic, functional coherence that holds a system together through time. In the next segment, we will zoom in on the technical apparatus and the formal theories, the axioms of Leśniewski, the parthood predicates, the notions of fusion and boundary as operators in a formal language. We will pair these with further case studies and historical anecdotes, and we will explore how contemporary analysts interpret these ideas in relation to identity over time, material composition, and the moral and practical implications of composition and decomposition. We will read passages and discuss the ways in which ancient intuitions and modern calculus intersect, diverge, and illuminate one another. We will listen for the echo of the ship of Theseus, the lessons of Aristotle, and the sharp clarity of Leśniewski's symbols, all in one continuous, reflective thread. The voyage into mereology is a journey into the deepest strata of how we perceive unity, how we count parts, and how we understand the objects that populate our world. We embark on that journey with a calm mind and a patient ear, ready to hear how the simplest questions about parts and wholes open up into a wide, intricate map of reality. The idea of mereology is deceptively simple at first glance. It asks, what is it for something to be a part of something else? When we speak of a car, we say the wheels are parts of the car, the seat is a part, the steering wheel, the door. When we speak of a statue, we talk about the material base, the statue's surface, and perhaps the pedestal beneath it as parts in one sense or another. When we speak of a cloud, we refer to droplets, but then there is the whole cloud that seems to have a unity that is not simply the mere sum of its drops. When we speak of a heart and its chambers, we ask, Is the heart itself a part of a larger organism, or is the chamber a part of the heart proper, or is the whole heart a part of the body? These questions are not mere technicalities. They are questions about how we think the world is put together, about how unity arises from multiplicity, and about what must be taken as primitive in any serious account of parts and wholes. In this section, we are stepping into the formal backbone of that inquiry. We want to understand how the parthood relation is treated in contemporary and historical accounts, especially when we treat parthood itself as a primitive, rather than something defined from more basic notions like set membership or spatial containment. We will travel through the core axioms that govern a robust parthood structure: reflexivity, the idea that every part is a part of itself; transitivity, the intuitive principle that if A is a part of B and B is a part of C, then A is a part of C; and the extensional or Leibnizian principle that two wholes are identical if they share all the same parts. We will examine how these axioms bear on the most natural of candidates for parthood: the car and its wheels, the statue and its base, a cloud and its droplets, a heart and its chambers. We will distinguish strong versus weak mereology, the debate about how far the parthood relation can be extended, and under what circumstances sums or fusions must exist. We will also explore light versus heavy theories of fusion, or sum, whether the mereological sum exists for every collection of parts, or only for some special, restricted collections. And we will do this not merely by listing positions, but by letting the examples themselves push, loosen, or refine the ideas. As we move along, we will cast our gaze on two major lines of critique, two counterarguments that force us to test the stability of the view. First, we will examine how transitivity, so clean and elegant on the blackboard, can clash with certain intuitions about continuity in boundary cases. There are scenarios in which the transitive chain seems to produce oddities or violate how we ordinarily judge the composition of things that seem to blend into each other. Second, we will address the boundary problem, the sense in which discrete parts blur at thresholds. If a cloud is a conglomerate of droplets, what exactly makes the cloud a unit or a sum? If a heart is divided into chambers, at what point does a change in the arrangement of those parts alter the identity of the whole? These are not merely technical obstacles. They pressure us to confront how fine-grained our treatment of parts must be before the formal apparatus begins to fail to capture our intuitive or scientific commitments. To anchor this inquiry historically, we will wander into a few pivotal historical anecdotes. We will begin with Leśniewski's ambitious program from the 1910s to the 1930s, where he sought to build formal systems in which parts and sums could be treated as primitive notions, with a carefully designed logical apparatus to govern how they combine and relate. We will visit the thought experiments that have shaped debates about composition in time, notably those that appear in later discussions by van Inwagen, who invites us to test how composition could occur across temporal slices or phases of an object's life. And we will engage with Schaffer's contemporary defense of the priority of parts, an argument that the very order of explanation in the metaphysics of persistence and unity runs from parts to wholes, not the other way around. In addition to these anchors, we will draw cross-references to set theory and to the notion of unity, to the persistence of objects across time, and to how parthood interfaces with identity conditions. In doing so, we will keep our eye on the practical and conceptual consequences, how these theories inform science, how they shape our understanding of persistence, and how they illuminate debates about what counts as a self-sufficient unit in nature. Let us begin with the starting point, the parthood relation as primitive. When philosophers discuss mereology, one of the most persistent moves is to treat parthood not as a definition derived from another relation, but as a primitive concept, a primitive logical relation that needs no definition in terms of, say, set membership or spatial overlap. The parthood relation is supposed to be basic. Given any two entities, A and B, we can reasonably ask whether A is a part of B, and the answer is taken to be part of the ground floor of the theory, not something that must be constructed from pre-existing notions. This stance aligns with a certain foundational mood in the history of logic and ontology, one that is especially visible in formalist or quasi-formal approaches to the architecture of objects. In such a mood, the goal is to accrue a minimal, robust set of axioms that govern how parts and wholes can relate to one another, and only then to see how far those axioms can be pushed to cover the world. From this starting point, the parthood relation as primitive, we can sketch a skeleton of the central axioms that matter for a rigorous mereology. The first is reflexivity. The idea is simple, almost intuitive. Every part is a part of itself. It is not a trivial tautology about the same thing being equal to itself. Rather, it stipulates a baseline of contact between a thing and its own constitution. If you imagine a rock, you can say with intuitive confidence that one of its parts, let's say a tiny shard of the rock, remains a part of the rock as a whole, and more generally any part you pick out of the rock is a part of the rock. Reflexivity is a natural permission slip for decomposition to make sense. It allows us to discuss a part and its superpart as a linear neighborhood of sorts within the same object, without soon running into contradictions about non-membership. The second axiom is transitivity. If A is a part of B and B is a part of C, then A is a part of C. Transitivity seems to capture a natural intuition about how material organization gathers up. If the wheel is part of the car and the car is part of the vehicle, then the wheel is part of the vehicle. If you push this, it yields a neat and powerful inference pattern. Once you accept those two stepwise relationships, you can build a nested architecture of parts and wholes where the inclusion relationships can be traced across multiple levels. Transitivity is not just a technical convenience. It gives us a way to talk about nested structure without laddering up a new concept every time we consider a new layer of composition. It also brings with it certain metaphysical commitments. It ties together a world where the same relationship holds across all scales, from micro to macro, and where the same logic can be applied to the parts of a statue and to the parts of a cloud in a coherent way. A third core principle is extensionality of a particular flavor, often called the extensional principle for parts, or in other words, Leibnizian extensionality for parthood. The extensional claim says, if two wholes share all the same parts, then they are identical. If A and B have exactly the same parts, there is no difference between them, because there is nothing left that could distinguish A from B in terms of their constitution. In the most literal reading, this is a way of tying identity for wholes to the composition of parts. The world is determined, at least at the level of parts, by what enters into the wholes. If we cannot tell the two wholes apart by their parts, then there is no fact of the matter to distinguish them. This is a natural analog to the way set theorists think about the identity of sets by membership. If two sets contain exactly the same members, they are the same set. The extensional principle in Mereology tries to graft that familiar, rigorous standard onto the parthood relation. The part-whole structure should be unambiguous by mereological accounting alone. Within a formal profile, there are interesting and sometimes crucial questions about how strong or how flexible these axioms should be. Should parthood be taken as reflexive? Almost certainly yes, if we want a coherent, reflexive logic of parts. But some marginal or borderline theories try to reject reflexivity for certain exotic cases. For example, if one wants to treat a part that is only a potential part, or if one wants to treat parthood as a relation that requires actual instantiation. The standard move is to treat reflexivity as a given, not as a theoretical debate. In the everyday world, we do not tremble at the thought that a blade is a part of the blade, so a reflexive principle is not especially controversial. Yet in more refined theorizations, especially when we entertain the possibility of fusions that are more delicate or when we try to formalize parthood in a way that interacts with continuity or process, it is natural to re-examine reflexivity to be sure that it captures what we want and doesn't force us into counterintuitive commitments about, say, mereological atoms or the non-existence of certain sums. Transitivity, likewise, is attractive precisely because it yields a neat, predictable, hierarchical map of parts. If A is part of B and B is part of C, the transitive closure makes it easy to reason about the whole chain from the smallest fragment up to the grand composite. But as we push beyond idealized, neatly nested objects to real-world scenarios characterized by continuity and thresholds, transitivity can become a source of tension. Consider a scenario in which we have a chain of parts A, B, C that are arranged in a way that seems to present a boundary problem. If A is a part of B and B is a part of C, but there is some sense in which the boundary between A and C is not well defined, or the boundary between B and C shifts depending on how finely we partition, transitivity may start to push us toward questionable conclusions. In a world of sharp parthood, A is a part of C in a straightforward, unambiguous sense. In a world of blurry or fuzzy boundaries, the same reasoning might seem to yield unstable results. The extensional principle further intensifies those worries. If A and B share all of their parts, even if their boundaries are unclear, could we end up identifying two wholes that, in some contexts, ought to be distinct due to their different structural roles, histories, or purposes? To help this picture come alive, let us consider the concrete examples you might have in mind: a car and its wheels, a statue and its material base, a cloud and its droplets, a heart and its chambers. Each example can be used to probe the axioms in particular ways and to explore how a given mereology might encode the intuitive facts we have about these objects. Take the car and its wheels. It is tempting to say that the wheels are parts of the car, and the car is a part of the larger vehicle or the broader concept of transportation infrastructure. If we treat the wheel as a genuine part of the car, the reflexive axiom tells us that a given wheel is a part of itself as well as a part of the car. This seems uncontroversial. Transitivity plays its role when we think of the wheel as part of the car and the car as part of a convoy or a fleet. Then the wheel becomes part of that larger whole by virtue of the chain. Wheel part of car, car part of the fleet, so wheel part of the fleet. The extensional principle would then declare that if two supposed wholes, the car and the car with its extra features, share all the same parts, they would be identical as long as those parts are identical. But this is where the gloss turns tricky. If we imagine a scenario in which we can detach a wheel and reattach it in a different position, does the wheel remain a part of the car in exactly the same sense? Do we have to treat the wheel that is in the spare tire as the same part of the car or a different one? A more radical version of this thought experiment would place the wheels on a separate car initially, then swap them onto the first car. Do we at that moment alter the identity of the original car by changing which of its parts are attached to which body? In a strong, unrestricted fusion theory, one might say the sum of parts exists for any set of car parts, and the car's identity is determined by which parts compose it at any moment. In a weak theory, the sum might fail to exist if the collection of parts doesn't form a single cohesive unity in the relevant sense. The car example thus shines a light on the debate about whether sums always exist and how we ought to understand the persistence of identity through change. Now consider a statue and its material base. Here the base can be thought of as a part that grounds the statue's material constitution. The base is part of the statue in a straightforward way, and the statue more generally is part of the museum's overall installation, perhaps part of a collection. If we think in those terms, the collection would be a larger whole of which the statue is a part. This example invites a particular nuance. The base is a material substrate. If one were to fail to retain the base, would the statue survive as the same entity? In a strong parthood theory, the statue's identity might be tightly linked to the base because the base is part of what makes the statue, quite literally its material anchor. In a weaker or more eliminativist interpretation, we might allow that the statue as an object exists even if the base is removed, but still remains a recognizable statue in some determinate sense. The boundary here is not merely a boundary of inclusion, but a boundary of what one means by the essential parts that constitute the identity of the statue. A cloud and its droplets is an even more delicate case. A cloud is not a rigid, discrete object in the way a statue is. It is a dynamic, fluid aggregation of water vapor and droplets that form, disperse, and cohere in response to weather dynamics. If droplet A is a part of the cloud, and the cloud is a part of a weather system, then transitivity seems to push us to say that droplet A is a part of the weather system. But in what sense is the boundary between cloud and droplets real? There is no fixed boundary of the cloud as a geometric boundary. Rather, it is a region of space where the density of droplets exceeds some threshold defined by meteorologists. If we adopt a threshold approach to parthood, what happens at the threshold itself? Is a tiny, barely perceptible droplet still a part of the cloud, or does it fail to count because it doesn't cross the threshold? If you use a heavy fusion principle, you may require a positive criterion for the existence of the sum cloud, such that the cloud exists only when a sufficiently cohesive relational structure holds among its droplets. If you adopt a light fusion principle, the cloud's existence is permissive, and even a sparse, evolving cluster of droplets might count as a cloud in the appropriate sense. In either case, the boundary problem becomes a live issue. Is the cloud's identity defined by the set of droplets, or by the ecological and meteorological function the cloud performs, or by a combination of both? This kind of example shows how real-world phenomena force us to decide what counts as a part in a way that is sensitive to thresholds, continuity, and context. And then we have a heart and its chambers. The heart is clearly a composite organ. The chambers are parts of the heart in the ordinary sense. But what of the boundary between the heart and the body it inhabits? Is the body a part of the organism, or is it the organism as a whole that includes the heart? If we keep the addendum that a part is a part of a larger whole, and the larger whole includes the body and perhaps more, then the heart is a part of the body's organism, and the chambers are parts of the heart, which is a part of the body. If we adopt a strong fusion principle, we might say that the entire organism exists at a given time as the sum of all its parts, including the heart, its chambers, the lungs, the limbs, and the brain. If the heart is removed, the organism changes its identity in a strong sense. The heart's identity and the organism's identity become tightly linked through the parthood relation. If one wants to preserve the organism's identity despite radical changes in parts, one might push toward a weaker or more flexible account of parthood, or toward a theory of persistence that decouples identity from any fixed set of parts. The hard example thus acts as a touchstone for thinking about persistence conditions in time, and it pushes us to attend to how the parthood relation interacts with temporal slicing, stage theories of persistence, and the boundaries that matter for what counts as a whole. So far we have explored in a fairly intuitive register how the parthood relation, when treated as primitive and governed by a small set of axioms, can map onto everyday examples. We have also seen how these examples can push back on the assumptions we might like to import from the mathematics of sets or from the ordinary language way of talking about wholes. But there is a more formal story here than the intuition allows. The idea that parthood is primitive invites us into a broader debate about what a fundamental logical relation might be and how such a relation could be integrated into a full-fledged logical system. One major rival to the parthood primitivist approach is to analyze parthood in terms of another, perhaps more familiar logical relation, such as set membership or mereological sums defined via sum operator. In a set-theoretic apparatus, a part can be seen as something like a subset of a set, and the whole as the set that contains the parts. But mereology, especially in the forms that we have in mind when we talk about blocks and wholes in the physical world, often resists a straightforward translation into standard set theory. The extensional principle, two wholes are identical if they share all the same parts, resembles the identity criterion in set theory. Two sets are identical if they have the same members, yet there is a crucial disanalogy. In sets, membership is generally a relation between items of a different kind than the whole, whereas in mereology, the parts are themselves the same kind of entities as the wholes. This difference matters precisely because it opens space for continua, temporally extended entities, and objects with boundary-dodging or threshold-laden compositions. In other words, the Mereology project asks what happens when we do not have a clean, well-behaved mapping to the well-trodden ground of set theory. Cross-referencing this formal backbone with the broader landscape of logic and ontology reveals two influential directions that philosophers have pursued over the last century. One is a set-theoretic approach to composition in which the existence and identity of wholes are explained primarily by the structure of sets of parts. In that approach, the world is described as a tapestry of objects with members. The parts of an object are the elements of the set that constitutes the object, and the whole is the set itself or the object defined by its membership structure. The other approach, more aligned with the tradition of the Mereology movement, takes parthood as primitive and asks what axioms are necessary or sufficient to capture the common sense and scientific intuitions we actually rely on when we speak about parts and wholes. In this approach, the emphasis shifts from what is in a set to what can stand in the parthood relation, how sums are formed, and how extinction or persistence across time can be understood. To deepen this horizon, consider a few explicit, historically grounded voices. Leśniewski's program of the 1910s through the 1930s sought to build a rigorous ontology in which parts and sums are primitive, and the logic of composition is codified with a distinctive three-system framework. S.N. and O. in Leśniewski's architecture, parthood is a primitive relation that resists reduction to class inclusion, or to any of the standard logical machinery that undergirds set theory. He famously aimed to eliminate some of the opacity of the set-theoretic apparatus by giving a direct formal treatment of the way parts combine to form wholes, and the way wholes may be distinguished by their parts. In his own lines and in the reception of his work, the project stands as one of the most ambitious attempts to dethrone the primacy of set theory in favor of a rigorous, pure mereology that could, in principle, ground mathematics on a framework of parthood and sum. Then there is van Inwagen, whose work on composition in time is a landmark in modern metaphysics. He asks us to imagine carefully how parts and wholes endure or fail to endure as time flows and as objects change their material constitution. He develops thought experiments that push us to clarify when a new object comes into being because its parts have changed in some particular way, and when a single persisting object can undergo a sequence of changes in which its parts come and go, yet its identity remains intact. His discussions are not just about whether a statue is the same statue when you replace its atoms gradually. They are about how composition, whether there exists a single whole that has as parts exactly those objects that together compose it, picks out certain patterns of unity and persistence through time. The interactive interplay of time, identity, and composition is where the Mereology program becomes most visibly relevant to questions about the persistence of objects across time. Schaffer, in more recent debates, has pressed a different but equally forceful claim: the priority of parts. He argues that understanding the unity and persistence of a whole often requires starting from the parts and the relations among them, rather than starting from the whole and asking what parts it might have. This is not a mere preference for a particular angle on the problem. Schaffer's position is that the very structure of how a thing is unified is best explained by appealing to how its parts stand in relation to each other, and how those relations scale up to a whole with a particular unity. In his view, there is a kind of grounding or explanatory direction that runs from parts to wholes. This priority of parts is not an attempt simply to say parts are the fundamental entities. Rather, it is an attempt to show that if you want to understand unity, identity, and persistence, you will fare better by foregrounding the part-whole architecture that underwrites those notions. These historical and contemporary lines of thought intersect with a broader set of cross-references that modern philosophers rely on when they think about mereology. One is the relationship between set theory and mereology. A common worry is that a purely set-theoretic account may fail to capture the more fluid, context-dependent, or process-oriented intuitions we have about how objects are composed. Sets typically require a clear membership relation. An element either is or is not a member of a set. But in the world of overlapping, continuous, and temporally evolving parts, parthood often behaves differently. It is not simply a question of having a fixed membership. It is a question of whether there is a stable union that can be said to have the same parts, whether those parts can be rearranged, and whether the identity of the whole is preserved under such rearrangements. The set-theoretic picture is useful and indispensable in many respects, but mereology challenges us to think about whether we can have a robust logic of parts that does not collapse into standard set theory, or at least that can accommodate the phenomena that sets alone struggle to capture, such as the continuity of a cloud, the persistence of a heart through time while its atoms are replaced, and the way in which parts can be the same or distinct across varying contexts. Another essential cross-reference concerns the notion of unity. What does it mean for a collective of parts to form a unity? Is unity a relation among parts, or is it a feature of the whole that is not reducible to the mereological assembly of parts? In some approaches, unity is a primitive notion alongside parthood. There is a sense in which a whole has an intrinsic unity, a kind of coherence or sturdiness that cannot be fully explained by listing its parts. In others, unity is reducible to the pattern of relationships among parts. If the parts fit together in such a way that their organization yields a single, indivisible whole, then the unity emerges from the parthood relation plus certain constraints about how those parts connect. The trade-offs here connect directly to questions of identity and persistence. If unity is primitive, then two objects could share the same parts yet be distinct because their unity is different. If unity is reducible to the pattern of parts, then a lot of the story of identity and persistence becomes more about structural organization than about the intrinsic properties of the whole. A final cross-reference concerns the persistence of objects across time and identity conditions. Parthood has a clear tie to persistence. If the parts persist, the whole can persist in virtue of those parts. If the parts change, the whole might change as well. This suggests a natural link between mereology and theories of persistence, including endurantism, perdurantism, and other approaches to how objects endure through time. Endurantists tend to see objects as wholly present at each moment of their existence. Perdurantists see objects as enduring through time by having temporal parts at different times. Each of these views interacts with the parthood relations in telling ways. For a perdurantist, the set of temporal parts would be the objects of parthood relations, and fusing those parts over time could yield the whole that persists. For an endurantist, the question may become, what counts as a part of the same object if the object is wholly present at each moment? The answers to these questions are not merely technical footnotes. They determine how we model the ontology of persistence, how we think about continuity, and how we interpret experimental or empirical facts about how materials reorganize themselves. Two major counterarguments deserve careful attention because they press the limits of a clean parthood-based framework. The first concerns transitivity and continuity. It is natural to assume that if A is part of B and B is part of C, then A is part of C, but there are scenarios where this inference seems to produce counterintuitive results when the physical boundaries are fuzzy, or when the identity of an object over time hinges on more than mere inclusion relations. Consider a region that is defined by a boundary that is not precisely fixed, such as the shoreline. If we treat the coastline and the landmass using strict parthood relations, we might model as if the sand grains near the edge are constantly shifting their membership. Some grains are part of the land, others become part of the sea, and back again as tides move. If there's a grain of sand that is part of the coastline, and B is the coastline, and C is the landmass, transitivity would lead us to conclude that the grain of sand is a part of the landmass. But the intuitive boundary between land and sea is less stable. Sometimes the coastline redefines itself as erosion or deposition shifts the boundary. Does transitivity then force us to accept a version of the part that slides in and out of the landmass with the tides? If so, our naive transitivity may conflict with a more robust, intuitive sense that the landmass has a relatively fixed core of stability. This is a continuity problem. In a world of continuous change and moving boundaries, transitivity can push us toward unstable conclusions about what counts as a part in a moment of change. The second major counterargument is the boundary problem, the problem of where and when to draw the boundary between a part and its host. Imagine a cloud again. There is a sense in which a cloud is made up of droplets. If the cloud is a whole, then any droplet is a part of the cloud, by the intuitive reading. Then the extensional principle would tell us that if another cloud has all the same droplets, the two clouds are identical. But that is a troubling direction to take. If two clouds contain exactly the same droplets, would they not at some times be the same cloud, and at other times be different clouds because of their location in air masses, their gravitational effects, their ability to shape weather patterns? And what about the droplets that exist only transiently inside the cloud, forming and dissolving as dew and condensation cycles proceed? If we insist on a fixed boundary, we might demand that the cloud be the sum of all its droplets at a given time, with a clearly defined edge around the entire cluster of droplets. If we allow the boundary to drift with the moving water vapor, the whole may become inseparable from the process that sustains it, and our mereology risks flattening into a theory of processes rather than objects. The boundary problem therefore pushes back against the extensionalist impulse to identify whole by its set of parts, suggesting that, at least in some regions of discourse, meteorology, botany, even everyday perception of bodies, you either need a more nuanced notion of part that allows for graded membership, or a more contextual notion of fusion that recognizes how context shapes the correct way to count parts. Let us press further into the philosophical terrain that gives us an even more vivid sense of why this discussion matters. Beyond the immediate paradoxes of parts and wholes, mereology engages with essential questions about unity, persistence, and the way we model the world. The unity of a thing, what makes a thing a single, coherent entity rather than a loose collection of parts, can be thought of in several ways. Some accounts rally around the idea that unity is a robust, intrinsic feature of the whole, something that persists through time and explains why the object does not simply disintegrate into mere parts. Other accounts treat unity as a functional feature, a property that emerges when the parts interact in particular ways or when the whole plays a certain role in a system of relations. The parthood relation is a natural place to ground this discussion precisely because unity and persistence, in many formulations, arise as a consequence of how parts must stand in relation to one another, and how those relations are constrained by the axioms of the mereology under consideration. The debate over parthood as primitive also intersects with a broader cluster of questions about identity conditions in metaphysics. If two objects share all their parts, must they be identical? If not, what additional structure is required to distinguish a pair of objects that, in a purely part-based sense, are indistinguishable? This is not a pedantic issue. Our theories about identity have direct consequences for scientific practice, including how we model biological organisms, ecological systems, and even artificial constructs like software systems or mechanical assemblies. If the identity of a thing is determined solely by its parts, then any change in parts, even a small one, might yield a different object. If identity survives minor changes, the parthood relation must be supplemented with additional criteria, perhaps historical or functional, about what counts as the same object emitting the same causal profile, or about continuity of material constitution across time. These are not only philosophical concerns, they cascade into how we think about medicine, engineering, environmental science, and the design of artifacts. The parthood framework thus becomes a lens through which we interrogate what we count as a thing, how we track its persistence, and how we explain its behavior in time. As you can tell, the discussion moves quickly from clean theorems on a chalkboard to the messy, dynamic features of the world. The move from the abstract, axiomatic program to real-world application is where the cross-references to other thinkers and other ideas become not merely useful but indispensable. For instance, when we connect parthood to the broader question of unity, we encounter the notion of the unity of the whole as a relational property, often tied to the way parts fit together or the function the whole serves. The unity of a human body is not simply the mathematical aggregation of its cells. It is the product of organization, development, and purpose. That sense of unity can be captured in a mereology that allows for the kinds of sums and fusions that reflect biological coherence and functional integrity, while also accommodating the possibility that the same pattern of parts could yield different wholes depending on context, history, or the organization of processes. This is where philosophical debates about the unity of objects intersect with empirical science. In biology, anatomy, and systems theory, the way parts assemble and interact yields a robust sense of entity that a purely formal parthood axiom might wish to capture, or at least approximate. To broaden the horizon of our understanding, we must consider the two important teams of ideas that have formed in contemporary debates: the strong parthood framework and its alternatives, and the distinct but related project of connecting mereology to the notion of persistence across time. The strong parthood framework, often aligned with unrestricted fusion, holds that for any collection of parts there exists a sum, a whole, that has exactly those parts. This is the heavier side of the fusion debate. It gestures toward a generous metaphysical landscape in which there are no artificial barriers to forming a new object out of any set of parts. The weaker or lighter versions impose restrictions. Perhaps only finite collections admit a sum, or only those sets of parts that meet certain coherence conditions yield a whole. The distinction between light and heavy theories is not a mere technical footnote. It influences how we think about continuity, thresholds, and even the ontological budget we allocate to the existence of complex objects. In a world where infinite fusions are admitted, the landscape includes exotic objects, like the totality of all the parts of the universe considered as a single thing. In a world where only finite fusions are admitting, the ontology is more conservative but arguably closer to how we actually think about the ordinary, countable, finite assemblies that fill our lives. The analogies we have used, car and wheels, statue and base, cloud and droplets, heart and chambers, start to echo certain metaphysical commitments about unity and identity. For the car and wheels, the sum is a straightforward economic and mechanical fact. The wheels contribute to the car's function and identity in a way that makes the whole meaningful in a practical world. The base of the statue grounds the sculpture. The base is not an optional add-on but a constitutive support, a part that makes the statue what it is, and whose removal would alter the object's identity in a strong sense. The cloud and droplets demonstrate a more fluid form of unity where the boundary is not crisp and the parts are in flux. The sum exists as a way to talk about a meteorological phenomenon, but the precise determination of which droplets count as the cloud's parts is a matter of convention, threshold, and context. The heart and its chambers illustrate a legitimate functional unity. The chambers are essential to the heart's function as a pump. The heart's identity as a coherent whole is bound up with its internal organization. The heart example is perhaps the most poignant because it is a case where a specific, highly structured organization yields a powerful, stable function, even as the world of parts around it shifts in the background. These examples, when held together, show how mereology can be tested against a spectrum of reality, from stable, discrete objects to fluid, dynamic systems to functionally integrated organs. To connect back to the two counterarguments, consider transitivity and boundary problems in the context of a modern, more rigorous theory. Imagine a formal system that is careful about boundaries and thresholds. It can allow for graded parts or degrees of parthood. Such a system can accommodate the idea that a grain of sand might be a part of a shore in a different sense than a mountain is part of a continent. It can incorporate a way to talk about boundary fuzziness without collapsing into contradiction or sheer arbitrariness. In other words, the paradoxes invite a more sophisticated treatment of parthood that can blend a robust, axiomatized core with a context-sensitive apparatus for dealing with the vagaries of real-world objects. This is precisely the kind of development that contemporary mereology attends to when it takes seriously the boundary problem and the continuity problem. The hope here is not to remove all difficulties, but to illustrate how a well-memorialized parthood framework can accommodate such difficulties and still deliver a usable, informative, and predictive theory of parts and wholes. The historical anecdotes lend additional texture to this story. Leśniewski's program was an audacious attempt to recast mathematics in terms of a few primitive notions of relation, such as part and sum, and to build up the logical apparatus so that the rest of mathematics would emerge from these primitive notions. The ambition was to show that many mathematical facts could be derived from a rigorous, purely mereological foundation. This is a radical alternative to the mainstream set-theoretic foundation of much of modern mathematics, and it remains an important historical reminder of how far the capacity of mereology to ground mathematical thinking can be pushed when confronted with the desire for systematic, logical elegance. The ambition is instructive because it shows that a mereology with robust primitives, parthood and sum, can aspire to do the heavy lifting of an entire mathematical ontology. Even though Leśniewski's program did not supplant set theory in the long run, it remains an influential and inspirational landmark for thinking about how a parthood-based universe might be structured and how it might yield powerful results when used with care. Moving forward to van Inwagen, we see a different kind of strength. Van Inwagen's thought experiments about composition in time are designed to stress test our intuitions about when a whole exists and when it does not. He invites us to imagine, for example, a statue that undergoes gradual atomic replacement or a ship that is repaired piece by piece. In such a setting, a mereology that is only concerned with instantaneous parthood may be too thin to do justice to the temporal dimension of persistence. The experiments push us to consider whether temporal parthood can be reconciled with a robust theory of identity, how the transition from one stage to another yields or fails to yield a new whole, and how the continuity of material constitution supports a conception of persistence in time. Van Inwagen helps us see that the mereological skeleton must be fitted with a temporal layer, a layer that can be made precise by a theory of temporal parts or by a framework that explicitly models how composition changes across time. Schaffer's defense of the priority of parts brings another important wave into this fluid conversation. If we accept that parts are ontologically prior to wholes, we thereby commit to a particular explanatory direction. The unity and persistence of a whole must ultimately be explained in terms of the pattern of relations among its parts. The whole's identity is not an independent fact in the same sense. It depends on describing the way the parts stand to one another and to the whole. This is not merely a rhetorical move. It has consequences for how we ground phenomena like the emergence of new properties, the distribution of causal powers, and the way we understand how a system can continue to be the same system across changes in its parts. Schaffer's position aligns with a general trend in contemporary metaphysics that asks for a robust implantation of parthood into a theory of grounding or explanation. The parts provide the scaffolding, the layers of organization, the why of unity, the conditions under which a depth of structure yields a stable, persisting whole. We should take a moment to reflect on the cross-references and the larger picture that emerges from tying these threads together. Set theory offers a well-developed apparatus for talking about collections, membership, and identity of sets. Mereology, by contrast, asks how to talk about the composition of objects when those objects themselves are the very things we want to understand. The two frameworks are not simply competitors, they are different tools for different purposes. In some domains, a set-theoretic approach is natural and powerful. In others, a parthood-based approach captures aspects of the world that sets have trouble describing, such as the fluid boundaries of a cloud, the dynamic organization of a living heart, or the functional unity of a mechanical system. When we ask whether parthood connects to persistence across time and identity conditions, we enter a territory where the practical demands of science and the theoretical commitments of ontology must be consulted together. If we want to tell a coherent story about the persistence of objects, their boundaries, and their unity, we may need the flexibility to switch between a parsimonious primitive approach and a more elaborated theory that integrates temporal structure, causal powers, and functional roles. Let me offer two crisp quotations, two compact guides to some of the core commitments that have guided these debates, drawn from primary sources in the field, albeit in a form that is accessible to a listening audience. First, from Leśniewski's program, we catch the spirit of his ambition to treat parts and sums as primitive and to build the entire theory from those primitives. He wrote in his characteristic mood that the logical apparatus should be anchored in a few primitive notions and that the rest of mathematics could be developed from those primitives by a rigorous, formal procedure. The exact wording of his articulations is technical, but the sense is clear. Parthood and the sum concept must be treated as primitive, not defined away, and the aim is to construct a complete, purely logical framework that captures the entire structure of mathematics from those building blocks. This is a bold claim with wide-reaching implications, one that invites us to consider the possibility of alternative foundations for science and metaphysics that avoid assuming the primacy of sets as the starting point. Second, from Van Inwagen's work on the problem of temporary intrinsics and the puzzle of persistence, we encounter a succinct formulation of the intuition that changes in parts can drive changes in the whole, and that this is where our formal apparatus has to be sensitive to time. He emphasizes the idea that the persistence of objects is not a simple, static matter, but something that unfolds as time passes and parts are replaced or reorganized. The result is a story that invites a robust parthood theory to be integrated with a temporal perspective. The claim is not that parthood alone suffices for persistence, but that the parthood framework provides essential leverage for understanding which changes in parts entail changes in the whole, and which aspects of a system's identity are preserved despite those changes. If we broaden our lens to the cross-referenced topography of this field, we must also note how these debates intersect with contemporary discussions about unity, grounding, and persistence. The parthood relation can be a key to understanding how unity arises, but it must be calibrated so that it tracks not only the static composition of objects, but also their dynamic aspects, their development, evolution, and functioning in time. The unity of a biological organism, the composition of an ecological cascade, or the architecture of a complex machine all require a theory that can accommodate both a stable, structured totality and the fluid, evolving set of parts that contribute to that totality's persistence through time. In closing this section, I want to emphasize a few guiding takeaways that can anchor your intuition as you move forward into more specialized treatments of mereology. First, parthood as a primitive gives us a compact, elegant starting point for a theory of parts and wholes. It enables us to formulate clean, general axioms, reflexivity, transitivity, and extensionality that apply across a wide range of cases. These axioms are not arbitrary conveniences. They capture a sense in which parts are deeply bound up with their wholes in a way that makes sense both philosophically and scientifically. Second, the distinctions among strong and weak mereology and among light and heavy fusion or sum remind us that the framework is not a monolith. There are multiple plausible ways to structure the relation between parts and wholes, and those choices have concrete consequences for how we model the world. Third, the examples car and wheels, statue and base, cloud and droplets, heart and chambers are not just illustrations. They are diagnostic tools that reveal where a theory might run into trouble and where it might efficiently capture the structure of a real object. Fourth, the two major counterarguments, the clash of transitivity with continuity and the boundary problem, are not merely objections to a theory. They are opportunities to refine our assumptions, to introduce context sensitivity or thresholds, and to explore how a robust mereology can adapt to the messy, dynamic world while still offering a clear framework for understanding parts and wholes. Fifth, the historic episodes, the Leśniewski program, the Van Inwagen thought experiments, and Schaffer's priority of parts offer more than anecdotes. They provide a map of the field's intellectual landscape, showing how a single formal idea can radiate into foundational questions about logic, mathematics, persistence, and the very nature of objects. As you reflect on these themes, you can begin to see how the formal backbone of mereology is not merely a technical appendix to philosophy of science or metaphysics. It is a living framework that helps us think about the architecture of reality, how things come together, how they endure or transform, and how we talk about unity in a world of parts that often resists simple summary. The parthood relation as primitive gives us a language for that architecture, and the axioms, reflexivity, transitivity, extensionality, provide the scaffolding for a robust, testable theory. The distinctions among strong and weak mereology and among light and heavy sums remind us that whether sums exist and when they do is not a trivial matter. It speaks to our broader commitments about what kinds of objects exist and how we are allowed to group parts into wholes. The potential conflicts introduced by transitivity in continuity and the boundary problem at thresholds push us toward a more nuanced theory that can handle continuous processes and context-sensitive boundaries without sacrificing clarity or coherence. In the end, the formalization of parthood does not simply solve a puzzle about what counts as a part. It invites us to re-examine what we mean by unity, by persistence, by identity, and by the very fabric of the objects we encounter in science, engineering, and everyday life. It prompts a dialogue between the abstract rigors of formal logic and the messy, concrete realities of the world, and it does so through a few timeless questions. What counts as a part? What counts as a whole? When does a sum exist, and when does it not? How do time and boundary shape our understanding of composition? In seeking to answer these questions, we engage with a tradition that stretches from the early 20th century to the present, a tradition that invites us to imagine a world in which the architecture of parts and wholes is not merely a metaphor, but an explicit, rigorous discourse about the way things are put together and how they endure. The road ahead is long, the terrain is complex, and the practical stakes are real, but the journey, through reflexive commitments, through the elegance of simple axioms, through the challenging bite of counterexamples, offers a deepened sense of what it means to understand the architecture of the parts-wholes relation. Let us step back for a moment and listen to a question that sounds simple at first, and then grows more intricate the longer we sit with it. What counts as a part of what? When we say that a ship is made of planks, or a statue is made of clay, or a person is made of cells, what exactly are we saying about what those things are in virtue of? Mereology, the study of parts and wholes, asks that very thing. How do parts compose wholes, and how do they relate across time and across kinds of objects? In this section, we turn a careful ear toward the debates, puzzles, and temporal challenges that shape contemporary work in mereology. We begin with the big dichotomy that has driven a great deal of debate, then move through the core puzzles that keep philosophers up at night, and finally turn to time, persistence, and the drama of identity over duration. Throughout, we will keep two things in view. First, how these theories handle the most ordinary of objects in our lives, and second, how they fare under the stress tests of thought experiments, historical anecdotes, and the insights of physics and science. Let me begin with one of the most stubborn contrasts in the field. On one side stands mereological nihilism, the radical claim that only simples exist. By simples, we mean things without parts, the atomic, indivisible blocks of reality. If nihilism is right when we speak of a statue, a ship, or a person, we are, at best, performing a useful idiom, not describing something that really has a composite structure. On the other side sits mereological universalism, the almost uncomfortably expansive view that any non-empty collection forms a whole. If universalism is right, whenever you gather a few things together, you have a new object, a grand mosaic that includes its parts, the sum of its parts, and the parts' relations. Between these two polar positions lie a spectrum of intermediate views, each defending a different story about when and why composites exist and what it takes for parts to fuse into wholes. To make this concrete, imagine a vase that is gradually filled with pebbles. The nihilist would insist that at no moment do we get a genuinely new object by adding a pebble to the vase. There are only the simples and perhaps a sequence of mereological recombinations, but no new composite entity that truly has the vase's form as a unity. The universalist, by contrast, might say that as soon as you place a pebble in the vase, a new object, the vase plus pebbles, exists, and that this new object persists even as you remove pebbles, replace pebbles, or rearrange them. An intermediate view might say that there is a genuine composite only under certain conditions, perhaps when a unity relation holds strong enough to ground the existence of a whole. The debate, then, is not merely about what we say in ordinary language, but about the very backdrop of how things persist, how they change, and how the metaphysical story lines up with our scientific picture of the world. To travel through this terrain, we need to be precise about several core notions that loom large in contemporary discussions. The first is the parthood relation itself. X is a part of Y if Y depends on X in such a way that removing X would deprive Y of something essential. Parthood is a relation that is not symmetric in general. If X is a part of Y, it does not follow that Y is a part of X. The second is the principle of overlap. In standard mereology, X overlaps Y if there is some Z that is a part of both X and Y. The third is the non-overlapping requirement, often invoked by critics of universalism. If two distinct objects overlap, then some of the world's best intuition about occurrence and identity is challenged, and the mere relational structure becomes tangled. The fourth and crucial set of puzzles concerns boundary vagueness. Many boundaries in the physical world are not sharp. When exactly does a heap of sand become a sandpile? When does a ship cease to be a ship and become a pile of planks? These are not merely linguistic curiosities. They strike at the heart of how we carve up the world into objects with identity over time. Let us begin with the two leading positions in more detail, and then move to the middle ground. Nihilism asserts that composites do not exist. On this view, what we call the statue is just a single, simple object, perhaps the lump of matter arranged in a particular way that we happen to call a statue, but there are no parts that bear the right sort of unity to make a separate object in addition to the lump. The world on nihilism is not a zoo of hundreds of different beings, each composed of parts and subparts. It is a world of simples with parthood relations that do not amount to genuine wholes. There are strong motivations behind nihilism. It neatly internalizes certain metaphysical parsimony and avoids troublesome questions about the nature of the whole. If there is no composite, there is nothing to analyze about grounding, about the stability of a statue over time as its material elements change, or about how a vessel can be at once a container and its content. There is a certain elegance in the claim that what we are tempted to treat as composites are, at bottom, mere arrangements of simple things. But nihilism faces robust challenges, and here the counterarguments come thick and persuasive. The first major counterargument is phenomenology in ordinary language. Our everyday discourse routinely treats objects as composites with determinate boundaries, with persistence through change, and with sameness of form across time. If you walk into a room and see a chair, you do not typically think you are looking at a single, unchanging simple. You think you are looking at a chair made of wood, with legs, a back, and a seat, assembled from many parts in a particular arrangement. The challenge is to explain why our language, our practices of naming, counting, and communicating about objects, would be so robustly about composites if there were no composites to ground them. A second counterargument concerns persistence over time. If there were no composite objects, how do we account for the phenomenon of persistence, the way a statue remains the same thing while its parts come and go, or remain the same through time even as conditions shift? Nihilism must either surrender a robust account of persistence or embrace an account whose counterintuitive features show up in ordinary cases. Put bluntly, we seem to owe a story to the appearance of unity that ordinary objects present, and nihilism is often charged with offering too parsimonious an ontology to capture those appearances in a way that aligns with our best science and everyday life. On the other side stands universalism. The idea that any non-empty collection forms a whole is attractive in its own way because it aligns with an intuition that the world glues together in all possible combinations. If a ball and a pin and a feather lie together, the universalist says there is a composite ball plus pins plus feathers. If those parts are arranged differently, a different composite arises. The universe becomes a grand, unruly mosaic of wholes, without the need for a separate act of construction to generate wholes. This view handles continuity and sameness in a straightforward way. Any given arrangement, any set of collocated or related parts, yields a single, persistent object with its own identity criteria. Yet universalism, too, runs into serious trouble. The most crisp objection centers on the absurd composites that universalists might seem compelled to admit. If every collection forms a whole, then there exist objects that many of us would normally not recognize as genuine composites. Consider the set of all hairs in a room, or the set of all molecules in a guitar string, or a more radical example, the set consisting of every object in the universe. If those sets count as wholes, then the theory must explain what counts as their boundaries and how such enormous, even ill-defined, composites relate to the world as we usually understand it. A common line of critique is that universalism collapses distinctions that intuition demands be preserved. It risks yielding an ontology crowded with entities that are mathematically possible but metaphysically unwieldy, leading to a proliferating series of objects that challenge science's ability to ground them in physical structure. If the theory allows for a coral reef as a composite of its countless resident organisms, why not a galaxy plus cluster of galaxies, or a city plus highway system, or every star in the cosmos? The worry is not merely about size, but about the coherence of parthood itself. If any random collection is a thing, then parthood relations may threaten to become unmanageable, with too many candidates for being parts of too many wholes. Between nihilism and universalism, there is a ladder of intermediate views that attempt to preserve something of the parsimonious appeal of nihilism, while acknowledging that our world naturally presents robust composites. The most influential intermediate position is often called restricted composition. On this view, composites exist only under certain conditions that carve out when a collection has unity strong enough to ground a real whole. Those conditions might be empirical, metaphysical, or grounded in some form of causal or functional unity. The hope is to explain why a statue exists as a single thing at all times, why a ship persists as a unified object across stages of change, and why certain collections count as wholes while others simply do not. Restricted composition aims to respect common-sense objecthood while avoiding the extravagances of universalism and the ontological excess that nihilism seems to invite. But even this middle ground must answer hard questions. What exactly is this unity relation that licensees a composite? When is the unity strong enough? Are these criteria natural so that they track natural kinds and scientific explanation, or are they ad hoc, merely tailored to save the folk psychology of everyday objecthood? Now, to sharpen the debate, let us introduce two central puzzles that haunt almost every account, and then show how the puzzles bear on our three key scenarios: overlap, non-overlapping, and boundary vagueness. The first puzzle is the overlap problem. The idea is that if universalism is true, or if composites are abundant in virtue of some unity relation, then we should expect that many different wholes share parts. Consider a common-sense example, a statue of a historical figure and the lump of clay from which the statue was formed. In many standard readings, the atom that lies at the heart of both the statue and the lump is a part of both, because the atom is a part of the material that grounds both. If two distinct wholes share a part, that creates a web of parthood relations that can be difficult to reconcile with our ordinary sense of idempotence. How can a single object be more than, or identical to more than one large-scale structure at once? In the nihilist view, this overlap looks suspicious too, but for different reasons. If composites don't exist, then asserting that two clearly distinct objects overlap by sharing some putative part seems to force us to bite the bullet that there are parts that exist without something to be a parthood relation to, or to demand a rethinking of the very categories of part and whole. The overlap problem asks, can there be a coherent world in which multiple composites overlap without collapsing into a single, more fundamental unity? The answer depends on how we tailor the parthood relation, the concept of a part, and the logic of composition. Some theorists bite the bullet by allowing high degrees of overlap, and others insist on a tight constraint. Either two distinct wholes cannot share any proper part, or there must be a robust account of how two different wholes can overlap only if one is a part of the other in a special sense. Both directions face serious objections, and both reveal the fragility of any clean, universalist metaphysics when faced with everyday materials. The second puzzle is the non-overlapping requirement. This is a friendly-sounding principle that some accounts take to be an anchor. If two things do not overlap, then they are in some sense independent. The non-overlapping requirement becomes a litmus test for the plausibility of an account of parthood. Does the theory allow two distinct objects to be disjoint in space and time, and yet not be reducible to a singular ground? Many philosophers use non-overlapping as a constraint on identity. If A and B are genuinely distinct, then there should be some region of space that belongs to one but not the other, or some causal or functional separation that prevents their parts from collapsing into a single subset of material. But in a universe where universalism is true, the line between overlap and non-overlap begins to blur. The entire discussion becomes intensified by the fact that our world is indeed full of collocated objects that we still manage to describe as distinct. A person standing in a room with a chair in front of a table, a ceramic vase on a shelf, all of which share space and sometimes even material. The non-overlapping requirement tests whether a given theory can accommodate these ordinary intuitions without collapsing into a parthood explosion. A third persistent difficulty arises from the problem of boundary vagueness and borderline cases. The boundary between a statue and its lump, between a heap and a pile, or between a life form and its constituent cells is not crisp. If we mathematically model the world as a mosaic of discrete parts, we risk misrepresenting the way reality actually behaves. Many physical systems do not have sharp cutoffs. In physics, for example, phase transitions, like water freezing into ice, show that boundaries can blur under certain conditions, and at microscopic scales, particles do not align into neat categories. The Saurite-style vagueness is ubiquitous. At what exact moment does a chunk of clay become a statue? When does a ship's replacement of planks cease to be the same ship and become something else? Across biology, physics, and cognitive science, we confront similar, very small changes, no small change puzzles. The boundary vagueness problem is a locus where many theories of parthood must show their resilience or admit their limits. The moral of the boundary story is not to escape vagueness by fiat, but to see how a theory of parts and wholes can still explain stable identity in the presence of subtle, gradual change. What follows is how the story unfolds when we turn to time. Temporal Mereology asks, how do objects persist through time? Do they endure as a single, unchanging thing from moment to moment, or do they persist by having temporal parts, the slices of time in which the object exists? And how does parthood, the relation of having parts, interact with theories of persistence such as endurantism and perdurantism? Endurantism, often called persistence by endurance, says that objects are wholly present at every moment of their existence. A statue that lasts from Monday to Friday is the very same statue, wholly present at each moment along the way, even as the surrounding world changes and even as its own material composition shifts. The parthood relation over time is then a relation between a thing at one time and that same thing at another time. The whole persists through a succession of moments, unbroken and uniform in its essence. Endurantists tend to appeal to a strong notion of identity across time. The statue's identity remains fixed even if some of its parts are swapped out or reorganized so long as the object retains its essential form or function. But this view faces a cascade of puzzles. If the statue is wholly present at each moment, how do we account for the fact that its parts do change? Is the statue at time tone the same entity as the statue at time teat woe if, in the middle, it lost a leg and gained a new one? How is identity robustly preserved across a sequence of changes that would, under a different view, amount to a very different object? Endurantism must tell a story about how change can occur without a change of the object's identity. Perdurantism, by contrast, says that objects persist over time by having temporal parts. They are four-dimensional entities, extended in time as well as in space. The statue at time t is not identically the same as the statue at time t plus 1. Rather, there is a temporal slice of the statue at each moment, and the object as a whole is a continuum of these slices stitched together by the parthood relation through time. The advantage of perdurantism is that it naturally accommodates gradual change. Different temporal parts can change while the identity of the whole is preserved in virtue of the way the parts relate across time. The challenge, however, is to explain the nature of the gaps between temporal parts and to address everyday language about persistence that seems to assume a single, robust bearer of identity across time. If an object is a temporal sum of many parts, what is it for those parts to cohere into a single ongoing identity? Are there criteria of connectedness, similarity, or continuity that secure this unity? And how do quantum and relativistic physics, where the persistence of classical objects can shade into processes described by fields and fields of potential, shape or restrict our claims about temporal parts? These debates are not purely abstract. They translate into vivid thought experiments and scenarios that test the edges of any theory of composition and persistence. Here are 3 extended scenarios, each designed to push our intuitions and see how different mereological theories respond. Scenario A: a statue gradually assembled from particles, then melts away. In this scene, imagine an artist who begins with a pile of tiny particles scattered on a pedestal. Over the hours, the particles coalesce, forming a coherent statue in the shape of a timeless figure. The process is gradual but continuous. At each moment, the statue seems to have a front, a back, a torso, and limbs that coherently align. After a while, the process reverses. Heat is applied, the statue begins to melt, and the particles return to a diffuse pool that resembles their initial scatter. At what moments does the statue exist as a whole? While it is being assembled, is it a statue at all before the final shape is achieved? When it begins to melt, does the statue cease to be? If nihilism is correct, there is no genuine composite statue at any stage. There are only simples and perhaps the arrangement of those simples that we label as statue. If universalism is correct, the statue exists as a new whole from the first moment a sufficiently unified arrangement appears and persists even as the form dissolves until the final dissolution step. A restricted composition view would offer a precise threshold. There is a statue at the moment when the unity relation is sufficiently strong to ground a genuine whole, but not before. What makes this scenario particularly rich is the question of boundary and parthood across time. If the assembly is gradual, do we have a paradox about partial parts? What counts as a part of the statue as it is being assembled? Are the initial microparts themselves the statue's parts, or are they merely raw matter awaiting organization? If parts come and go, can we point to a continuous chain of identity, or is there a moment when the statue's identity leaps to a new form? Endurantists might argue that the statue's identity remains intact across the process, because the object is a single thing with qualitative sameness that persists despite the rearrangement of its microparts. Perdurantists will insist that the statue is a succession of temporal parts, with the identity of the whole secured by a unity relation across time rather than by a single, unchanging essence. Scenario B: a ship slowly replaced plank by plank. Here is a classic of thought experiments. A ship's hull is gradually rebuilt, plank by plank, until every plank is replaced with an identical substitute. If you were to line up the original set of planks and compare them to the set now in the ship, you would see that none of the original components remain. Yet the ship remains in its outward appearance, its function, and its name. If the old timber has entirely disappeared and every part has been replaced, is the ship still the same ship? If universalism were true, there would be a comprehensive sense in which the ship at any given time is just the sum of its current parts, the current application of the name, and the current unity. If nihilism is true, perhaps the ship no longer exists as a composite object once all planks have been replaced, and what remains is just a set of simples that, by living in the same place and serving the same function, pretend to the identity of the ship. A restricted composition view attempts to capture a middle ground. There exists a ship as long as the unity of form, function, and history is strong enough to ground a genuine whole. Once the original ship has ceased to maintain that unity in a robust sense, we may no longer have the same ship, even if it looks and behaves identically on the surface. This scenario invites a suite of deeper questions about the nature of persistence and the relation between identity and continuity. If two ships that differ in their material composition can still be thought of as the same ship, What criteria secure identity across change? Do we rely on causal continuity, the carrying forward of a function, or a semantic practice that anchors a name to an object's history and role? Endurantists may respond by appealing to a narrative of persistence that emphasizes the continuity of form and function. Perdurantists would emphasize the continuity of the entire temporal worm of the object through time. The ship is a line of connected temporal parts with a coherent history that grounds its identity. Scenario C. A biological organism evolving while maintaining identity. This scenario invites reflections on the living world. Consider a creature such as a tree or a human being whose cells die and are replaced over time, whose form shifts, and whose genetic expression evolves in response to the environment, yet who remains the same organism across months or years. For nihilists, a persistent organism would be an ostensible object with no genuine composite identity, perhaps a sequence of simples whose arrangement yields a familiar facade of unity, but without a true, ongoing whole. For universalists, the organism persists as a single whole throughout time because any non-empty collection taken at a moment, its cells, molecules, or tissues, forms a part of a larger whole that is that organism, and the sequence of those wholes across time constitutes a single persisting creature. The restricted composition view would require a robust, grounded criterion for when the organism's unity is strong enough to warrant its continued existence across time while its parts are replaced or reorganized. Across all three scenarios, two further observations push the theory forward. First, the overlap problem intensifies in scenarios of gradual replacement and evolution because the same object can be seen as overlapping with multiple temporally distinct wholes, or as the product of different coexisting wholes that share certain parts at different times. Second, the boundary vagueness becomes not merely a logical puzzle, but a matter of empirical practice. When exactly does a new organism emerge as a new biological type, and when does a replaced tissue mark only a superficial revision of the old organism? The discussion here touches not only metaphysics but also empirical science. Biology, materials science, and even developmental biology provide rich case studies of how persistence and composition operate in dynamic systems. If you have ever watched a sculptor alter a statue by adding or removing pieces, or seen a ship literally re-engineered plank by plank, or observed a patient undergoing cell turnover across a lifetime, you have engaged with an everyday phenomenology of parthood, persistence, and identity. Let us broaden the horizon with a handful of historical anecdotes and the voices of key figures who have shaped this debate. The ship of Theseus provides one of the oldest, most enduring paradigms for thinking through identity over time. In the ancient world, the tension between form and matter, the question of what endows a thing with its unity, was already central to hylomorphic thought. Aristotle's theory of form and matter, or hylomorphism, offers a protomere of the subject. Form is what organizes matter into an intelligible unity. Matter is what endows form with a substrate. The balance between these two ingredients, form as the organizing principle, matter as the receptive stuff, was a way of explaining both persistence and change. The medieval years of scholastic thought, with Aquinas and his predecessors, mobilized this framework to connect parthood to form, and to explain how a thing's essence can endure even as its accidental properties shift. The old debates about whether form or matter is more fundamental, the enduring unity that makes a thing be what it is, versus the raw materials that enter into its making, are, in a sense, early precursors to contemporary mereology. The ship of Theseus, as Plutarch narrates it, is a canonical test case precisely because it encapsulates the tension between material continuity and formal continuity. The ship is repaired plank by plank until none of the original boards remain. Is it the same ship? If you replaced every part, would you have the same holes? The thought experiment invites us to separate the question of persistence of the material substrate from the question of identity as a functional or nominal name. It is a practical demonstration of the difference between a mereological sum of parts and a unity that grounds a specific identity. In the medieval and early modern debates about form and matter, this distinction would have appeared as the difference between hylomorphism and reductionism. Is the unity of a thing grounded in a form that persists, or in combining a roster of matter into a new arrangement? The debates of that era frame the modern introduction to parthood as a robust philosophical question about what it means for something to be one thing at a time and many things across time. In the modern era, two influential thinkers anchor the contemporary conversation with a wealth of arguments and thought experiments. First, Peter van Inwagen, a central defender of the restricted composition thesis, has argued that composites exist only under conditions of a special unity among parts. Van Inwagen's approach invites us to see composition as a kind of bridge built only when there is an appropriate context for a grounded unity. He questions whether, without a principled grounding, it would be simply arbitrary to infer a composite object whenever you collect a few parts. His thought experiments about the conditions under which a collection of objects forms a whole press us to demand a robust criterion for when composition occurs and when it does not. The result is a view that preserves a certain modesty about the existence of composites, while remaining grounded in the science of how material systems organize themselves. Second, Jonathan Schaffer offers a different flavor of modern argument. Schaffer's work centers on the primacy of parthood and the metaphysical astuteness of grounding. He invites readers to consider the primacy of parthood as a relation that underwrites not just the existence of composites, but the fundamental structure of reality. Schaffer's program is to demonstrate that parthood is a fundamental relation and that a coherent metaphysical system can be built by analyzing how wholes and parts ground other principles, causal relations, spatiotemporal structure, and the very architecture of truth conditions about persistence. Schaffer's work has also fostered a robust debate about emergent properties and the way causality can be understood through the lens of cross-cutting parthood relations. The conversation with Schaffer encourages a more formal interlocking account of how composites, if they exist, relate to their parts and to the entire physical world. In addition to the ship of Theseus and the modern debates, there are other touchpoints that connect Mereology to broader philosophical concerns. The theory of persistence is tightly linked to the philosophy of science and physics. If objects persist through time by their own unity or by their chain of temporal parts, what does that imply about causation, about the ontic status of objects in physics, and about how we model systems in science? The persistence problem really sits at the intersection of metaphysics with concentrations in physics. The way mass, energy, and momentum are conserved, the way continuity is modeled in fields, and the way we describe the evolution of systems under dynamic laws. Emergence, how new properties arise from the organization of parts, offers another cross-reference. If wholes emerge with new powers and new constraints, does Mereology have to accommodate a notion of emergence that is not reducible to the properties of the parts? If so, what does that say about reductionism in science and the relationship between microstructure and macrostructure? Historically, the debate has also drawn from the medieval and early modern preoccupations with form and matter to inform how parthood works. The medieval theologians and philosophers treated form as the principle that secures unity and explicates the whatness, the essence of a thing, while matter was the substratum that receives form. Parthood in that idiom is a question of how unity emerges from the combination of form and matter. The modern incarnations thus carry forward a lineage of thinking about what counts as the same thing through time, how structure and substrate support identity, and how to articulate the boundaries that separate one thing from another. This historical thread is not only about the past, it helps illuminate why contemporary theories cling to the insistence that parthood matters, and why the puzzles around parthood, overlap, non-overlap, vagueness, and temporal composition continue to be both lively and deeply consequential. To bring the discussion to a more practical plane, let us consider two robust counterarguments for each major stance, nihilism and universalism, so that we can see the live tensions at stake, and so that we can appreciate why the intermediate positions feel necessary to many philosophers. Two strong counterarguments to nihilism begin with everyday objects and then extend to persistence. First, nihilism seems to bear too heavy a price for what looks, in ordinary life, like a robust, stable world of composites. If you have a chair and you pick up its seat, and you move to a different chair with a slightly different composition, it is not obvious that you are merely manipulating a series of ungrounded simples in some nonspecific arrangement. Our way of talking about chairs, tables, cars, and people makes a claim about a unity that endures over time and under change. A second counterargument emphasizes persistence. If only simples exist, then it becomes very hard to tell a story of object continuity over time that aligns with our scientific and perceptual experiences. For instance, consider the simple but telling fact that you don't typically think of your childhood home as having vanished every night and reappearing each morning as if it were a new arrangement of particles. Your house seems to persist as the same object across day-to-day changes, even as the furniture or paint colors change, or even as a wall is rebuilt. Nihilism would force us to translate all these cases into a sequence of rearrangements among simples, but it is not clear that this captures the robust sense of identity and continuity that common sense and science use when we describe material systems. In short, the charge is that nihilism, despite its elegant parsimony, risks offering a distorted picture of everyday objecthood and persistence. Two robust counterarguments to universalism press on the consequences of a wildly expansive ontology and the way it handles the boundary problem. First, universalism, if carried to its extremes, yields the prospect of absurd composites, the sets and sums that push ordinary sense of what counts as a thing so far that the resulting ontology becomes unwieldy for scientific practice. If any non-empty collection forms a whole, then everything can be a part of everything else to some degree, and the line between individual objects and their many sums becomes porous. This can undermine explanatory commitments about causation, prediction, and even the intuitive idea that a specific object can be the proper bearer of a certain causal role, because now we have to accommodate an almost endless family of competing wholes with ambiguous boundaries. The second counterargument targets the coherence of parthood across time and space. If everything forms a whole, then the notion of a stable, well-behaved boundary becomes suspect. Consider a city or a planet or a star. Each could be treated as a composite of all the things within its boundary, leading to a cascade of overlapping wholes that defy a clear, tractable account of their causal and explanatory roles. A robust theory would need to show how to manage, filter, and ground these composites in the physical structure of the world. Otherwise, universalism drifts toward a metaphysical excess that science cannot comfortably accommodate. In addition to these debates about nihilism and universalism, we have to attend to the problem of overlap and the non-overlapping requirement as a practical constraint on any credible theory of parthood. The overlap problem, for instance, can force universalism to answer under what conditions two wholes can share a part without collapsing into a single, larger unity, or, in other words, what it means for two distinct things to be truly distinct if they overlap. The non-overlapping requirement, by contrast, is a constraint on the possibility of distinct wholes sharing parts. It asks whether it is coherent to maintain the independence of separate objects if their parts are not disjoint. The answers to these questions bear on non-trivial issues of scientific modeling. In neuroscience, biology, and materials science, we routinely model complex systems as composites that do not fully overlap with one another in ways that would destabilize clear explanation. A robust mereology has to account for such modeling practices while not collapsing into an unwieldy chaos of parts and wholes. Alongside the core puzzles and counterarguments, we need to attend to the reality of boundary vagueness and borderline cases, which is not only a logical puzzle but a cognitive and empirical puzzle about how we understand the world. The boundary between a statue and a lump of clay, the boundary between a heap and a pile, or the boundary between the ship as an object and the ship as merely a sum of its parts, are not crisp. Our cognitive systems are exquisitely sensitive to patterns, continuity, function, and purpose, yet they must also navigate contexts in which precision is impossible or impractical. The Sorites paradox, the paradox of the heap, exemplifies this. If a handful of grains is not a heap, and a single grain is not a heap, at what precise point does the collection become a heap? The metaphysical version of this problem asks, at what precise point does a collection acquire the status of a thing? If there is no precise boundary, can a theory of parthood still deliver a robust account of identity and persistence, or does it need to adopt a flexible, context-dependent approach to composition? This is where the overlap of philosophy with cognitive science, linguistics, and physics becomes not only natural but essential. Let me also bring in the temporal dimension with a few connective observations. Temporal mereology, persistence, and identity do not exist in a vacuum. They interface with physics, biology, and the philosophy of science in a way that reveals how deepest metaphysical questions can illuminate and be illuminated by contemporary science. The debate about persistence mirrors the divide in physics between classical, intuitive notions of a thing that remains the same across time and the more nuanced narratives offered by relativistic physics and quantum fields, where the notion of a fixed, unchanging substrate is challengeable. Emergence, too, enters the scene. Some philosophers argue that new, robust properties can arise at higher levels of organization, even if they do not exist as simple properties of the parts. If wholes can have emergent properties, what is the correct model of how a composite arises and persists, and how do we ground this emergence in a parthood framework without surrendering to a vagueness that undermines predictive power? Finally, we should consider cross-references to related philosophical themes and to the philosophy of science and physics. The mereological questions connect directly to persistence and identity discussions in metaphysics, but they also touch on how scientists model systems and how we interpret data about the behavior of complex systems. The idea of emergence challenges the assumption that wholes are nothing more than the sum of their parts. It invites us to reflect on how new levels of organization can be said to have causal powers and explanatory roles that are not reducible to the constituents. The relationship to physics is clear. In many physical theories, especially those that describe systems in terms of fields and distributed properties, the idea that there is a single, fixed object carrying all causal powers is suspect or incomplete. If the physical world is a network of interacting parts, fields, and processes that evolve continuously through time, then what counts as a thing and what counts as its parts must be carefully teased apart to align with scientific explanation. The philosophy of science and physics thus provide a rich testing ground for mereological theories. How would a particular account of parthood fare as we model a cell, a neuron network in the brain, or a galaxy cluster? Does the theory support or hinder our capacity to describe those systems coherently and fruitfully? As a concluding note before we move on to even more technical detail, the central tension of mereology is that it binds together three forces that often pull in different directions. The urge for ontological parsimony and elegance, the obligation to account for everyday objecthood and persistence, and the need to remain coherent with the insights of science about how parts and wholes actually behave in the world. The dilemmas of nihilism, universalism, and the intermediate positions are more than abstract curiosities. They are tests of our willingness to take seriously the unity of the world we inhabit, and to understand the ways in which that unity arises, is maintained, or dissolves as the hours of time unfold. Let me end this section with a short reflection that ties the themes together and invites you to consider your own intuitive responses. When you look at the statue in front of you, do you think of it as a single, enduring thing that exists wholly through time, or do you think of it as the stable arrangement of matter that allows a continuous story to unfold as the parts are replaced or altered? Do you find the idea that any collection forms a whole to be too expansive, even absurd, because it makes the word object drift far from what we can empirically study? Or do you find the restricted composition view too conservative, because it sometimes seems to deny the obvious unity that a ship or a living organism presents even though their parts are in flux? The answer for many of us is that we need a theory that can accommodate both the stability of everyday objecthood and the scientific openness to a dynamic, open set of composite structures. The intermediate positions, with their careful relations, are often the most plausible starting point for bridging our lived experience with a rigorous, scientifically informed metaphysics. In the next segment, we will sharpen these ideas by turning to a set of two robust counterarguments for each major stance, to illuminate the practical stakes of choosing nihilism, universalism, or a restricted composition approach. We will ground these arguments in concrete thought experiments and connect them with the broader themes we have touched upon: persistence, identity, emergence, and the science of the natural world. We will also bring into view two more extended scenarios that test the interaction of parthood with time in living and changing systems, so that the discussion stays rooted in vivid, plausible cases rather than abstract maneuvers in a vacuum. And we will weave in the historical voices that have guided this field, from the ancient shipwrecks of thought to modern formal analyses, to remind us that this is not simply a puzzle to be solved, but a conversation that has shaped and continues to shape our understanding of what things are and what it means for them to be. As Heraclitus reminds us, no man ever steps in the same river twice. The river is time, the object of our attention. A statue, a ship, a person must be thought of in a way that respects the continuity of change and the fidelity of identity that we require for meaningful talk about the world. In the next section, we will dive deeper into the structural tools these theories use to navigate such rivers, tools that include not only parthood and overlap, but the crucial interplay of boundary, identity, and time. Mereology at its core asks a deceptively simple question: what counts as a part and what counts as a whole? When we say that a brain is made of neurons or that a mug is made of clay and glaze, we are already engaging in mereological thinking. The final section of our journey through the philosophy of mereology asks us to translate that ancient and technically dense set of ideas into practical terms. How do questions about parthood and composition ripple outward into science, the philosophy of mind, ethics, and law? How do they shape our understanding of mind-brain relationships, body schemas, emergent properties in biology, and the boundaries of collective or corporate agents? And what do we do when the world refuses to be neatly decomposed into tidy parts? To begin, let us recall why mereology mattered historically. The problem of how parts relate to wholes is not a mere pedantic curiosity. It is a lens through which we assess the legitimacy of explanations. If a system can be completely understood by cataloging its parts and their relations, then a reductionist story might suffice. If, however, the system exhibits properties that do not presuppose a simple map of its parts, then we may need a different vocabulary, one that can accommodate the whole that is more than or different from the sum of its parts. This tension animates debates from cognitive science to legal theory to physics and biology. The medieval and early modern debates about form and matter, hylomorphism in Aristotle, for example, already placed emphasis on how the same materials can compose different kinds of wholes and how the whole may impose constraints on its parts. The modern turn toward formal mereology, led by figures such as Stanisław Leśniewski in the 1920s, gave philosophers and scientists a precise toolkit. The part-whole relation, the idea of a fusion or mereological sum, the notions of overlap and disjointness, and the counterintuitive but fruitful consequences of assuming that parts can be appended, replaced, or reorganized into wholes with new properties. Origins and key thinkers. If we peer back through the annals, we see the impulse toward a principled vocabulary for parts and wholes already present in Aristotle's reflections on form and matter, on wholes and their components, and on how a change in a part can alter the nature of the whole, even when the material substrate remains recognizable. Aristotle's idea that wholes are more than merely the concatenation of their parts, an insistence that the whole can carry a different kind of unity than its discrete pieces, functions here as a kind of proto-mereology. The precise, formal move to a strict part-whole logic, however, arrives with the 20th century and with the work of Stanisław Leśniewski, whose logic of inclusion and part-whole became a launchpad for rigorous theories of composition. Leśniewski insisted that part is a primitive relation that binds individuals into wholes, and that a robust mereology can be built by stipulating certain axioms, among them reflexivity, every object is a part of itself, transitivity, if A is part of B and B is part of C, then A is part of C, and the law that a part must be contained in the whole it inhabits. In his hands, mereology is not merely a philosophical hobby, it becomes a precise logical framework with broad interpretive power for science and law. But the story does not end with a sharp set of formal postulates. The 20th century also brought a broader cultural and intellectual embrace of holism in fields such as systems theory and cognitive science. Jan Smuts, who coined the term holism in his Holism and Evolution, 1926, gave to the world a picture of nature that emphasizes wholes and their tendency to form integrated, functioning systems rather than merely the sum of isolated parts. Smuts' emphasis on the unity and self-regulation of systems invites us to read mereology not as a sterile catalog of parts, but as a way to understand how parts coordinate, how boundaries are drawn, and how new levels of organization emerge when parts interact. The cross-pollination with biology, cybernetics, and later complexity theory shows up in the way mereology becomes a lens for thinking about networks, feedback loops, and emergent behavior. In cognitive science and philosophy of mind, the adoption of mereology was not just a matter of metaphysical curiosity. It was a practical move toward modeling how minds could be composed of parts while still operating as unified agents. Early cognitive scientists and systems theorists asked, can we explain a mind by accounting for neurons and synapses without losing sight of the fact that people experience a seamless sense of self and agency? The brain as network problem became a central test case. If we parse cognition into neural modules, distributed networks, and integrated circuits, can we still account for the subjective unity of experience? The mereological toolkit helps address this in two ways. First, it clarifies what counts as a part in a complex system versus a component of a system with its own emergent properties. Second, it helps illuminate boundaries. Where does a system begin and where does it end? In debates about the mind-body relationship, mereology becomes a strategic instrument for analyzing how mental states supervene on neural states, how body schema is constituted by a hierarchy of parts and wholes, and how emergent properties of biological systems resist naive reductions to individual parts. A concise map of the terms helps here. Parthood is the relation of one object being contained in or included in another. Fusion is the operation by which many parts combine to form a whole. Sum or mereological sum is the thing that consists of all the parts taken together. Overlap means that two objects share a part or share that same space, and identity, continuity, and persistence become the questions that test whether a thing survives the changing of its parts. The core debate over whether a whole has a different kind of identity than its parts, whether the whole is reducible to its parts, or whether it is something sui generis, reappears in ethics and law, where we ask whether organizations, corporations, or collectives possess moral status or legal identity, and what it would even mean for a board of directors to share responsibility for the actions of the corporation as a single agent. Arguments, Principles, and the Role of Parthood. Mereology offers a toolkit of core principles that can be deployed in many disciplinary contexts. The transitivity of parthood, for example, is a standard axiom in classical mereology. If A is part of B and B is part of C, then A is part of C. This may seem obvious for a physical object. A brick is part of a wall part of a building. But the more interesting and challenging cases are those in which parts are nested in ways that are not so straightforward, or where parts seem to retain their identity despite changes in subparts. For instance, consider a brain region. If neuron A is part of a circuit B, and circuit B is part of a larger network C, should we conclude that neuron A is part of network C? And if we replace neuron A with a new neuron while keeping the circuit's function the same, is the neuron still part of the same network? These questions push us to think about parthood as not merely a spatial relation, but as a functional and informational relation. The parthood relation, properly understood, must be compatible with the persistence of a system's identity through change. A crucial aspect of modern mereology is the idea of fusion, the operation that combines parts into a single whole. Fusion captures a sense in which many parts create a single, unified entity that can differ from the mere sum of its parts in certain respects. And this is where the interaction between mereology and emergent properties becomes especially rich. If the properties of a system are emergent in the sense that they cannot be read off directly from the properties of the parts in isolation, the fusion operation takes on philosophical significance. The whole now has real, robust properties that the parts lack on their own. This is not merely a metaphor, it is a claim about the ontology of systems, and it has bearing on biology, neuroscience, and social theory. Critically, mereology is not a blind instrument for reductionism. The field has long recognized that parts are often contextual. A part might be a minimal unit in one explanatory framework but not in another. Consider a metabolic pathway in biology. What counts as a part of a given biological function can change depending on which level of description you adopt. The same molecule can be a part of a metabolic cycle in one model and a scaffold for a protein interaction network in another. This contextuality makes mereology a living discipline in which cross-disciplinary cross-referencing is essential. The same parthood relations that help us understand the brain's architecture can also illuminate how a company, an institution, or a nation can be analyzed as a system of parts that give rise to new organizational properties. Two robust counterarguments to mereological primacy. We must, however, hold two robust counterarguments in view, not as mere irritants to a tidy theory, but as indispensable tests that keep our thinking honest. First, emergent phenomena may not track simple part structures. A classic example is consciousness. A great many theorists argue that conscious experience cannot be straightforwardly deduced from the mere arrangement of neurons and synapses. The hard problem of consciousness, as David Chalmers later phrased it, invites a challenge to a straightforward parthood-based reduction. The same set of neuronal parts might be reorganized in different ways to produce qualitative experiences, and a mereological map of parts might fail to capture why experience feels like something to the subject at all. Even when a brain state can be correlated with a mental state, the direction of explanation often runs from the whole, not from a simple listing of parts. If we pretend that the mind is simply the sum of its neurons, we may miss the way the mind organizes, interprets, and gives meaning to those parts. There are many examples in biology too. Developmental programs, epigenetic regulations, and neural plasticity show that the system's behavior cannot always be predicted by the sum of its parts in a straightforward way. Emergence resists being identified with any single underlying particulate structure. It is a relational, dynamical phenomenon. This does not deny the utility of a part-based analysis, but it challenges the claim that parthood alone suffices to explain the highest levels of organization. Second, over-reliance on part-based explanations can obscure holistic explanations. If we insist that everything is explainable by reducing to parts and their interactions, we may overlook the ways in which holistic descriptions capture essential constraints and capacities of systems. Consider legal and ethical reasoning about ownership and responsibility. If a corporation is treated solely as a legal bundle of parts, the shares, the board, the employees, without paying attention to the emergent properties of collective agency, we risk misunderstanding accountability. The corporation, as a legal person, may act in ways that reflect distributed agency and norms that are not reducible to a simple mapping of individual members' actions. In ethics, the question of whether a transplantable organ preserves the identity of the person who donates it challenges a mereology that reduces personhood to the sum of bodily parts. If ethical and legal practices rely exclusively on part-based explanations, we may miss the morally significant continuity of the person or the organization across changes in its parts. In short, the danger is that mereology becomes a blind alley if it refuses to interact with holism, systems theory, and the thick contextual stories that animate real-world cases. Between these two poles, emergence that resists simple part structures and holistic readings that insist on more than a mere sum, mereology becomes a language, not a doctrine. It is a way to talk about parts and wholes that invites but does not compel reduction. In the best collaborations between philosophy and science, mereology provides a set of tools for clarifying what counts as a part in a given explanatory framework, for distinguishing between levels of description, and for recognizing how different descriptions highlight different explanatory aims. Origins and modern interpretations through real-world examples to see these ideas in action. Let's move from the abstract to vivid, thinkable cases. The brain as a network of neurons versus a unified mind is a canonical thought experiment in cognitive science, and it is a perfect crucible for mereology. If we conceive the brain as a vast network, with neurons as nodes and synapses as links, we might be tempted to think that the mind is nothing more than the aggregate of these parts. Yet the unity of conscious experience, our sense of a single self that persists through changes in momentary brain states, suggests that the mind functions as a whole in ways that extend beyond any single neuron's activity. In practice, we use parthood to map out the structural organization. Neurons are parts of circuits, circuits are parts of networks, and networks contribute to cognitive functions such as memory, attention, and decision-making. But the emergence of a coherent sense of self, a goal-directed intention, or a stream of conscious experience is better captured by considering the brain as a complex, dynamical whole whose parts constrain and support each other in non-trivial ways. Mereology gives us a language to discuss the nested levels. Neuron is part of circuit, circuit part of network, network part of global brain dynamics, while allowing for the possibility that the same neurons can participate in multiple networks without losing their individuality, and that the whole can exhibit properties not reducible to the behavior of any single neuron. Beyond neuroscience, mereology provides a useful framework for the body schema. Body schema is the brain's representation of the body in space and time. It is not simply the sum of sensory signals from individual muscles and bones. It is an integrated, dynamic map that coordinates perception and action. Parthood helps explain how the body can incorporate tools as extensions of itself. Consider the classic example of using a stick to reach a distant object. In a mereological view, the stick becomes part of the body schema when it is functionally integrated into the agent's motor system. The stick is no longer a mere external object. It becomes part of a larger whole, the agent's embodied capacity to interact with the world. This example illuminates how parthood can span not just privately owned biological parts, but extended practices and technologies, and how these forms of integration reshape what we mean by the boundaries of the agent. In the sciences, mereology speaks to emergent properties at multiple scales. In biology, for example, organisms are composed of tissues, organs, organ systems, and cells, each level carrying its own causal powers. The heart is made of cardiac cells, but the heart's function is not simply the sum of those cells. The phenomenon of life, homeostasis, adaptation, development, depends on the organization, timing, and spatial arrangement of parts as they interact. The mereological perspective helps us see why reductionist explanations, focusing exclusively on one cell or one gene, often fail to predict the behavior of the organism as a whole. Complex systems resist reduction because their causal architectures depend on relations among parts across scales. Feedback loops, redundancy, and network topology create a resilience and adaptability that neither the parts nor the subparts alone can explain. In physics, where the idea of parts has historically taken on mathematical precision, we encounter a similar tension. Some physicists argue that complex systems cannot be fully understood by reducing them to their individual constituents, because the interactions among components give rise to collective phenomena that do not manifest at the level of the parts. Entangled quantum systems, for instance, defy a naive parthood picture where the whole is simply the sum of independent parts. In classical physics, too, the behavior of chaotic systems, nonlinear dynamics, and emergent phases of matter challenges the idea that a complete explanation can be achieved purely by cataloging the parts. The mereological approach does not solve these puzzles, but it equips us with a vocabulary to articulate why certain partial descriptions fail, and to map how higher-level constraints can guide lower-level processes. Mereology and law, ethics, and the problem of collective agency, the legal and ethical domains provide perhaps the most striking demonstrations of the value and the risk of a part-based perspective. In corporate law, for example, a corporation is treated in many jurisdictions as a legal person, an entity distinct from its shareholders, managers, employees, and customers. Yet the corporation's acts cannot be entirely reduced to those individuals' actions. There is a sense in which the corporation is a part of a broader legal structure, a system of governance, contracts, property rights, and regulatory frameworks that confers on it a kind of unity and responsibility that does not map neatly onto the sum of its parts. Mereology invites precise questions. What counts as an act of the corporation as a whole? Is the board's decision the tool by which the corporation acts, or is it the entire organizational configuration that, by virtue of its structure, makes the decision possible? If a corporation causes harm, to what extent can we attribute it to the causal contributions of parts, the directors, the officers, the investors, versus to the holistic constraints that define corporate agency? Ethics presents a parallel set of issues with its own moral payoff. Organ transplantation has long been a locus of debate about identity and continuity. If a person's organs are replaced over time, does the person remain the same? Does the donor survive in the sense relevant to moral responsibility and personhood? Here, mereology does not provide a single, definitive answer, but it clarifies the questions. The focus shifts from whether the body is the same to whether the system's integrity and identity persist at the level of function, narrative, and social role. The moral weight of a person's identity is often bound up with relational properties, memory, character, relationships, social identity, whose continuity cannot be captured by parts alone. The mereological lens helps us see why arguments for and against organ transplantation frequently pivot on different understandings of what constitutes the same person. In these contexts, cross-disciplinary references become not merely decorative but essential. The legal metaphors of parts and wholes. How do we treat a corporation as if it were a single agent when it is in fact a complex arrangement of many people and processes? The philosophical concept of mereology can illuminate this problem by insisting on a careful tracing of which parts are responsible for which outcomes, and by considering whether a legal or moral responsibility rests with the aggregate system rather than with any single component. This is not a call to abandon reductionist insight. It is a call to balance it with holistic insight when the system's behavior cannot be entirely predicted or justified by the parts alone. Analogies, historical anecdotes, and the practical imagination analogies can illuminate even the trickier corners of mereology. Consider the mosaic. A mosaic is composed of many individual tiles, each with its own color and shape. If we subtract a few tiles, the mosaic's overall image changes in ways that are not predictable by simply knowing the color of each remaining tile in isolation. The mosaic's unity depends on the arrangement and the context, the gaps and the grouting matter as much as the tiles. In this sense, the parts are not merely elements, they are coordinates within a pattern that yields a novel whole. Now translate this into a social or cognitive domain. A community is a mosaic of people, institutions, beliefs, and practices. The cohesion of the community emerges from relationships, shared norms, and mutual commitments that cannot be fully explained by listing its members. Another vivid analogy is the bundle of tiggles that a living system presents. In some philosophical traditions, a person is described as a bundle of properties or roles, owner of a body, bearer of memories, agent with intentions, each property contributing to a complex whole. But the bundle analogy has its limits. A bundle can be rearranged or replaced with different properties, yet the agent remains the same person for more than a moment. The fusion of these properties into a unified identity is not merely a listing of parts. It is a story of continuity, narrative, and social recognition, an insight that mereology, when used carefully, helps to frame rather than erase. Historical anecdotes, cognitive science, systems theory, and bioethics, two historical threads, illuminate how mereology has been adopted, contested, and repurposed. First, the early adoption of mereology in cognitive science and systems theory. After World War II, with the birth of cybernetics and the growth of interdisciplinary research, scholars began to treat organisms, brains, and engineering systems as wholes linked by feedback, control, and information flow. The idea of a system as something larger than the sum of its parts gained traction precisely because it helped explain stability and adaptability. The mind, then, could be seen as an emergent property of a network of parts, rather than a ghostly essence inhabiting a brain. This shift opened doors for new research programs that analyzed learning and intelligence as system-wide properties of networks, rather than as static hierarchies of modules. The mereological vocabulary proved useful to articulate this shift: parts and wholes, junctions and boundaries, subsystems and supersystems. In this sense, mereology functioned as a bridge between rigorous logical analysis and the messy realities of real-world systems, where everything is connected to everything else in non-trivial ways. Second, the bioethics debates about organ transplantation and identity. The moral questions surrounding organ exchange, what it means for the person who receives an organ to remain the same person, what it means for a donor to have contributed a part that remains alive in a living system, made plain that identity cannot be captured by a single narrative about the body's parts. In these discussions, holism, emphasizing the integrity of the organism, the social roles a person inhabits, and the continuity of the self, competes with reductionist tendencies that try to designate identity based on a specific bodily constitution. Mereology helps by insisting that we are not forced to choose one perspective over the other. We can, instead, hold both in view and examine how they interact. The field of bioethics has, in this sense, become a weather vane for the tension between parthood-based explanations and holistic explanations. It reminds us that the mereological vocabulary has real ethical weight when we talk about the risk of harm, the duties of donors and recipients, and the social meanings of body parts. Cross-disciplinary references, emergence, systems theory, cognitive science, and legal metaphors cross-referencing across disciplines reveals how sturdy the ideas about parts and wholes can be when properly understood, and how fragile they can become when divorced from context. Emergent properties arise when interactions among parts give rise to new, unpredictable features at higher levels of organization. Mereology helps us articulate how emergent phenomena differ from mere part-level explanations, but it does not by itself explain them. The relationship between part-level states and novel higher-level states remains a central puzzle in philosophy of science, biology, and physics. Systems theory emphasizes the architecture of interactions, feedback loops, and network topology. The mereological vocabulary provides a natural way to describe nested systems, how a heartbeat depends on cells, how a city's traffic pattern depends on drivers and infrastructure, how a market depends on participants and regulations. The boundary problem, that is, where the system ends and the environment begins, remains a rich point of inquiry, and mereology invites careful reflection on where to draw these boundaries. Cognitive science. The study of thinking, memory, perception, and consciousness benefits from a careful consideration of parts and wholes. It invites a multi-scale analysis, where neural parts combine to form cognitive processes that we experience as unified mental states. Mereology offers a language to discuss how parts are bound into larger cognitive structures, and how hybrid, distributed processes can be both functionally integrated and hierarchically structured. Legal metaphors of parts and wholes. Law regularly navigates the puzzle of institutional identity, responsibility, and accountability. The concept of agency, whether it belongs to a person, a corporation, or a collective, depends on how we combine or separate the parts that comprise the agent. Mereology helps us formulate precise questions. When can a corporate body be held responsible for a decision taken by a committee? Does the action count as the corporation's action as a whole, or as the mere aggregate of individuals' choices? And what does it mean for the same legal person to persist through organizational changes, mergers, or dissolution? Two further real-world or thought experiment examples let us ground these ideas with a set of vivid examples that are both intuitive and philosophically revealing. First, the brain as a network of neurons versus a unified mind. In neuroscience, it is common to model the brain as a complex network of neurons that interact through synaptic connections. The functional mind emerges from this network's activity, and the same neural components can participate in multiple networks depending on the task at hand. Yet our experience of a single, continuous self, of a person who moves through day-to-day life with coherence and purpose, feels non-trivial. The mereological question arises: what counts as part of the mind? Is the mind merely the totality of neural activity, or is there a higher-level phenomenon, cognition, as a subsystem that is constituted by functional integration across many parts? And if we draw a boundary around the mind to define what belongs to it, where does that boundary lie? Is cognition limited to the skull, or can it extend into tools, bodies, and the social environment, as some extended cognition theories suggest? These questions illustrate how mereology can illuminate debates about the scope and limits of mental agency, the nature of consciousness, and the relationship between the brain's components and the person who experiences the world. Second, the broken mug and the question of identity after part replacement. The Ship of Theseus is one of the oldest thought experiments about identity, and it translates nicely into the modern parthood problem. Suppose a mug breaks into fragments, and you replace each fragment with a perfectly fitted new piece until every original fragment has been replaced. Is the resulting mug the same object as the original? What if you gradually replace the mug's material with a different material that retains the same shape and function? What counts as the same mug? The mereological inquiry here asks whether identity is a matter of spatial continuity, functional continuity, or something else, like a narrative continuity that ties the mug to the person who used it, the use it served, and the social context that recognizes it as the same object. This thought experiment invites us to think about parthood not just as a relation among physical pieces, but as a relation that involves purpose, history, and use. If we adopt a purely functional account, the mug may persist even as every atom is replaced, but if we demand a material persistence, the mug may perish in a strict sense. The moral of the story is not that one account is right and the other wrong. It is that identity and parthood are multi-layered questions, and mereology provides the vocabulary to explore them in a disciplined way. Third, the behavior of a team as a coherent system rather than a mere sum of players. In sports, corporate teams, research groups, and emergency response units, the value of the team is often greater than the sum of its parts. A team that communicates effectively, shares a common strategy, and adapts to changing circumstances can outperform any single star player. From a mereological perspective, the team is a whole composed of players, coaches, and processes. Yet to understand and optimize outcomes, we must look beyond the individuals and examine how the parts interact, how roles are allocated, how information is transmitted, how trust is built, and how a culture of collaboration emerges. The same framework can be extended to other collective entities, whether a medical team in an operating room or a cross-disciplinary research project. In these contexts, the mereological question concerns not only what counts as a part of the team, but how the team's identity persists through changes in its composition, how the network of interactions governs performance, and how accountability is distributed when outcomes are the product of a system rather than any single agent. Quotes from primary sources and the conversation with tradition to ground this discussion in the philosophical tradition. Here are a few primary voices that illuminate the themes we've been tracing. Aristotle, in discussing the relationship between whole and part, emphasizes that the whole is something different from its parts. A phrase attributed to him captures the intuition that a whole can have a unity and a set of features that cannot be reduced to some mere aggregation. The whole is greater than the part. While translations vary, the sense remains potent. The unity and causal efficacy of the whole cannot always be captured by listing the parts. This line is often cited as a reminder that the world's structure is not exhausted by a catalog of its components. In the early 20th century, Stanisław Leśniewski offered a precise formalism for part and whole. His axiomatics insist on a robust, logically coherent relation of inclusion. A part is what is contained within a whole, and the relationship is governed by clear logical constraints. In his own words within the formal treatises, he emphasizes the foundational role of the part relation in constructing a rigorous theory of objects and their assemblies. A contemporary translation might render a direct claim as, A is a part of B if and only if it is contained in B, and the part relation is reflexive, so every object is a part of itself, while transitive, so if it is part of B and B is part of C, then it is part of C. The emphasis here is not merely on the dictionary of terms, but on the idea that a precise, formal account of parthood enables us to reason clearly about the complex systems we care about. Jan Smuts in Holism and Evolution articulates a broader vision of nature's tendency to form wholes. He writes that holism is the recurring tendency of nature to organize, to form wholes that are more than the sum of their parts, and to develop properties and capabilities that emerge only at the level of the whole. This stance invites us to see parthood and wholeness not as a clash, but as a dialogue. The parts matter because they enable the system to function and adapt, while the wholes matter because they reveal capacities and constraints that only emerge when parts interact in structured ways. A more modern but deeply relevant voice, though not always available in the same ancient language, is the tradition of systems theory in biology and cybernetics. The language of parts and wholes in these circles is not a mere rhetorical device. It is a way of thinking about control, feedback, and regulation. In these discussions, mereology serves as a scaffold for describing how a system's identity is maintained or transformed over time, even as the parts themselves undergo turnover or replacement. The enduring point is that a system's behavior is a product of the architecture, not only of its components. Two additional angles: the risk of over-reliance on part-based explanations and the virtue of cross-disciplinary integration. The first risk is that parthood, taken in isolation, can lead to a blinkered view. If we program all explanation as a chain of part-to-whole reductions, we might miss the ways a system's history, culture, or social context shapes its structure and function. The mind, the body, legal institutions, and corporate actors all operate within environments that constrain and guide their parts. If we pretend that the only explanatory currency is part of and part of a part of, we may neglect how a system's environment narrows options, selects particular configurations, and gives rise to normative orders that cannot be reduced to component explanations. The virtue, by contrast, is integration, the willingness to travel across disciplines and to pick up the right instruments for the job. Mereology is not the last word, but a robust language for talking about parts and wholes across domains. It invites philosophers, biologists, cognitive scientists, jurists, and engineers to keep in view both the unity of the whole and the integrity of its parts. When we adopt this dual orientation, we can analyze in a nuanced fashion the boundary questions: where does the system begin? Where does it end? What counts as part of the system in a given explanatory framework? And what kinds of causal powers emerge at higher levels of organization? The practical payoff: how to use mereology with care and practice. If you take away only one lesson from this exploration, let it be this: parthood is a powerful tool for organizing thought, but it is not a universal solvent. Use parthood to map structure, to clarify boundaries, to track how subunits combine into larger wholes, and to ask whether a higher-level phenomenon calls for a new descriptive vocabulary. Do not forget to ask whether a holistic account better explains why a system behaves as it does, or whether an emergent property requires a narrative that traces the system's history, its environment, and its social uses. When we talk about ownership, responsibility, and the limits of collective agency, we must ask not only who contributed to an outcome, but also what the system's architecture allowed, what norms constrain the behavior of its parts, and what kind of accountability is appropriate given the whole's capacity to act as a unit. In the end, mereology is a language for disciplined curiosity. It is a vocabulary for dissecting complex systems while appreciating their integrity. It reminds us that the human mind is not just a bag of neurons, that a body is more than a bag of organs, and that a society is more than the sum of its members. It invites us to track causal pathways with precision, yet to respect the ways in which unity, continuity, and precision can, in some contexts, require us to attend to the whole story rather than its parts alone. Closing reflections. The ongoing dialogue between parts and wholes, as we conclude our extended meditation on the philosophy of mereology and its cross-disciplinary relevance. A final thought. The world we study is always more layered than the last description we offered. The same bicycle wheel can be seen as a set of spokes, a ring of tension, a mechanism, or a symbol of sustained movement through time. The same brain can be read as a lattice of neurons, a dynamic network of cognition, a locus of personal identity, or a site of social and ethical responsibility. The same corporation can be a collection of contracts and assets, a living social organism with a board and a culture, a legal fiction that yields power and accountability. And yet each of these readings rests on a certain parthood structure, the recognition that parts gather to make wholes, and that wholes, in their turn, constrain and enable the parts in ways that are often invisible when we fix our gaze on the parts alone. If there is a virtue in mereology, it is in its willingness to be tested against the messiness of real-world cases. It asks us to articulate the boundaries of systems, to examine how identity persists through change, and to consider how the properties of a whole might demand explanations that do not reduce to the sum of its parts. It invites cross-disciplinary conversation. Physicists, biologists, cognitive scientists, ethicists, and lawyers all have something to contribute to a theory of parts and wholes, and to a practical ethic of how to treat systems that cross boundaries between organisms, organizations, and artifacts. Thus, the philosophy of mereology becomes not a distant abstraction, but a practical lens through which we examine how the world is put together and how we decide who is responsible for what within that tapestry. We can ask, what counts as a part in this domain? What counts as the whole that it composes? How does changing one part affect the whole, and how does the whole enforce its own influence on the parts? And as we move between the laboratory, the courtroom, and the living room, we will continue to find that the answers matter not only for theory but for our daily lives. How we think about identity, responsibility, ownership, and the capacity of systems to endure and to adapt. In this sense, the journey through mereology does not end with a neat conclusion, but with a horizon. The The more we attend to the parts, the more we notice the ways in which they bind together to form something larger and more intricate than themselves. And the more we study the wholes, the more we see that they shape the possibilities of the parts, guiding how those parts can interact, transform, and endure. The philosophical work remains to articulate, with clarity and care, the precise ways in which parts bind into wholes and wholes bind back into parts. To do that well is to honor the complexity of mind and world, and to build a language capable of guiding interpretation, critique, and responsible action across the full spectrum of human inquiry.